Welcome to the live stream of the Datrium vBrownBag build day. It's finally here. We've been preparing for the week, as you've seen on Twitter, and here it is. We're about to begin. Joining me for the build day is Devin Hamilton. Welcome to the live stream.
Good morning, sir. It's a pleasure to be here. This is the first one of these that I've done, so I'm pretty excited, and we've had a lot of fun setting up for this. It's good to meet you, Alastair.
Yeah, it's been really good. And so, Devin, introduce the lovely people to what it is that you do here at Datrium.
Sure. I am the Director of Systems Engineering at Datrium, and so I have the pleasure of working with the systems engineering team in the field most regularly, and we develop solutions that really advocate for the need that the customers bring to us. I also spend a lot of time training our partner reseller community and working with our product management teams to really be responsive to what the needs of the field are.
Excellent. And as usual, we're going to start with a customer environment that's a built vSphere environment with a few virtual machines on it, and then we're going to deploy in the DVX solution. And I guess one of the things we should do is preface and look at what we're actually going to build today.
Sure.
And funnily enough, Devin has some slides, so if you'd like to pick up the clicker and we'll bring the slides on.
Sure. We wanted to kind of represent in graphics what it is that we're doing today, and really in pictorial, it's relatively simple. Our solution is referred to as open convergence, and so what we're deploying today is really part software defined and then part hardware, and tying that together into a cohesive cluster. So we've got some ESX hosts. In fact, today these are represented by both compute nodes that we sell, and these are Datrium DVX compute nodes. And then Alastair has brought with him his lab, which we've also then brought into the environment to really represent what it would look like when a customer does what we call a mixed mode install. And a mixed mode install simply means that our solution can use the existing servers that a customer has and deploy software on them. We install some flash in them, and then they become part of this cluster for I/O and for performance computing and data services. But if that customer needs additional servers, we can bring those in and have a full turnkey solution in combination with our data node. So what this looks like here is that we've got really just any x86 server would do. We put some flash in those. So in the case of the Datrium DVX data nodes, they come from the factory with flash. The customer gets to pick how much they want and so on. Those servers are kind of built to order. So really any mix of their servers, our servers within the same cluster are fine. That's all connected on 10 gig Ethernet. And then what we're doing is we're plumbing those into a Datrium DVX data node. And the data node is really the foundation of the implementation. The software is there. It is the resilient capacity. So what we've built up in the lab is to have a data node with 2 Datrium compute nodes, and then a separate chassis that has all of your kit in it. And we tie those two together with network. And ultimately what ends up happening is that we're going to be, today during our build process, deploying our hyperdriver in the form of a VIB. So this is a vSphere installation bundle. We're going to demonstrate a couple of different ways to deploy that, and that we'll use the user interface methodology, and then we'll also use the CLI methodology to give the audience here a look at kind of how this thing can deploy. When we do that, what we're going to do is basically interface with ESX in this case. Datrium supports several different hypervisors. Our example today for build day is focused on ESX. That does represent the majority of our customers today. We do support Red Hat Enterprise Virtualization. We support persistent volumes in bare metal Linux or KVM OpenStack environments as well, and Docker. But today, for simplified sake, we're sticking with ESX. It's really the common install that we see most of our customers doing. The neat thing about Datrium is that as we deploy that hyperdriver VIB, those services come online dynamically, so we won't be seeing the need to do server restarts or anything like that. Those services come online. We grab a hold of the flash that's going to be turned into a large read cache for us. We grab some CPU, and that CPU is going to be obviously developing all of the back-end energy and potential we need for performance I/O and computing and running your applications that you're going to be testing. But the neat thing is that as we add more servers, we go faster. So really, the bigger the cluster, the faster this goes, or the larger you can scale the application payload, if you will.
Yeah, that's one of the things I see in this architecture, is that it's a little bit like a conventional storage array. It's not at all like a conventional storage array, but as I'm thinking about it, The data node, which is where all the persistent storage is like a disk shelf in a conventional array.
Yeah.
And then each ESX server, that vib, the hyperdriver, is like a storage controller.
Yeah.
And so it's got its performance tier attached to the storage controller. And every time you add another ESX server, you're adding another storage controller to your SAN.
Yeah.
And so the storage controller never becomes the bottleneck the way it often is in a dual controller array.
That is an incredibly accurate assessment, and really the one that we have kind of leveraged to talk to our customers about how this works, in that the data node is very much the resilient capacity. It is the truth of the environment. It represents where all the writes go, which means that the hosts are stateless, and yet all of the compute I/O comes from the host, where CPU cores are abundant, where I can make commodity flash an abundant resource.
Yeah, it's much cheaper to buy another compute node, and it doesn't have to be from Datrium. It can be any hardware vendor.
Yeah, literally.
And you can get way more CPU per dollar there than you can inside a conventional storage array.
Yeah.
And we've got one of the data nodes sitting here behind us, just on show. These things have relatively little CPU and moderate amounts of RAM because all the hard work, they're really just a disk shelf, and that's just being a network endpoint and some data protection.
Yeah.
But the hard compute work is all done in the ESX server.
That's right. And some of the stuff that we'll show today is that basically all of the pre-work around specific data services that you would traditionally find on a storage array are in fact now owned by the host. And so really referencing this in the pictorial here, we are distributing a service that's running in user world mode. So instead of running something like a virtual appliance or running as a kernel mode driver, both of which are not conducive to I/O performance or really resiliency, we're running as a service in user space, and that gives us direct access to the hardware that we can grab flash, we can grab CPU, but we're tangential to the kernel core, meaning that if our software is forcibly removed in some way, the host lives on.
Right.
This also means we can be polite along other storage.
To be careful about it, this is user mode inside the ESX server in VM kernel user mode.
Indeed, exactly, precisely. So the cool thing about this is that when we deploy, all of the functional services are happening within that host construct, and this means that really anything, even base RAID calculation, is done up in the host. Encryption, deduplication, compression, all the organization of bits into VM queues for locality of data, all of the constructs of the basically the block structure or the file system underneath the covers. This is all being done by the host, and so it really gives us a lot of agility to grow the environment and anticipate in a very predictable way how much performance we can scale over time for a customer.
Cool.
Yeah.
Now, do we have more slide in that one, or are we going to get into actually doing some real work?
I think we can actually get into doing some real work. I mean, the next thing that we would cover was really kind of talking about, what and where and what is open.
Let's come back to that.
We'll come back to that.
I think the lovely folks out there watching would like to see us actually build
That's a good idea.
Start building in DVX.
Cool.
So we've got this shelf. We've got our current vSphere environment. So I've brought the vBrownBag traveling lab with me. Two Supermicro little tiny half-width 1U servers, host 1 and 2. And as you can see, they're on the top of the stack here. So at the top we have the vBrownBag lab, the 2 servers in there, and some networking. Down below you can see the white 2U of the data node that we're using. Now that one, we're using the
variants of the data node. And so we're highlighting the new all-flash data node here. We have the traditional disk mode where we have basically 12 spindles at 4 terabytes each. So we're 48 terabytes raw. We expect then what gets presented to VMware is about 26.4 TB when we factor in base RAID calculation with RAID 6. That's before erasure coding, and then obviously file system components and things like that.
And we have also in that same rack those 2 compute nodes, which are the black ones that you'll see. In the lab, my 2 ESX servers, because we're going to reuse them and reuse the flash in them to be compute nodes in the DVX cluster, I haven't built vSAN on that because decommissioning and recommissioning vSAN multiple times in a week is significantly painful. And so I'm just using the local storage in each of the nodes. I haven't built them into a cluster.
Sure.
But we will add them into the DVX cluster along the way.
Yeah.
Now, follow the quick start guide. The quick start guide is included in the box. So we'll play the unboxing video in a little while, but we have the quick start guide that walks you through the process of deploying this as included in the box.
And for those who are watching, we do provide a screwdriver. And so we did make use of that screwdriver because there's a custom Datrium screwdriver that you get. But that's kind of, a lot of our customers think that's a big deal.
It's a nice thing.
Yeah.
So they buy the entire environment for a screwdriver.
Yeah, it's basically the screwdriver. Everything.
Seems...
We just throw in the DVX data node and the software and everything. It's good.
All right. So as we scroll through this quick start guide, it should tell us what we need to do.
Yeah, for orientation, the essence of what we want to do is make this as easy as possible for the customer. So, once you get through the unboxing and you've done your rack and stack, really the intent is plug it into the network, get out of the data center as quickly as possible, get back to a comfy conference room or back to your desk, and everything else is done typically via an Avahi zero-conf config. So we're going to discover the thing and then go through and set it up. And so the quick start guide just really walks us through that.
So it walks us through what to find in the box, how to rack and stack. I was interested that it walks us through also removing the power supplies and the actual controllers, and then I thought, well, if I'm racking it, I want it to be light.
Exactly.
I decided that's why we're told how to remove and to reinstall these things.
Because it's substantially lighter when you remove both power supplies and both controllers.
And rack mount kit's included in the case, and here's how to identify. And there's the Datrium screwdriver, not in focus, but there is the Datrium screwdriver. And lots of direction about reinserting the power supplies and the controllers.
Yeah, the system is serviceable with field replaceable components, and so we have spares depots throughout North America and soon abroad, so that we can service the system in the field very quickly. We also have spares kits that a customer could have on site, and so they would be able to make quick reparations if there were to be some kind of significant component failure, and that makes it a lot easier. We also separately service the batteries. We're using a battery backup for vRAM, and we'll talk about that later in some of the architecture content.
Yeah, and in the unboxing video, we showed that as well.
Yeah.
So each of the controllers has multiple networks, and for this, we're using the 1 gig Ethernet network for management. We have an IPMI port, which again is 1 gig Ethernet. We're using 10 gig SFP ports for this. There are options for 25 gig.
Indeed, yeah. So we come plumbed from the factory with a couple of choices. In the default 10 gig configuration, you have 2 SFP ports and 2 10 gigabit Ethernet ports per controller typically. You can then also select multiple 25 gig ports now. That's also in a refreshed offering that we came out with recently.
Right. And so you then cable up. So there's the 2 different configurations. You then cable those up, and really importantly, you take a photo of this little...
Yeah, that's important. There is a serial number that we're going to need as part of the zero-conf address and setup, and so one of the easiest things, just as a top tip, folks, is just sneak your camera phone back there and take a quick picture of that, and it makes it a lot easier to find that reference later.
And then it's gone to scrolling whole page at a time. Cables are in, symmetric cabling across the 2.
Yeah.
One of the traps, of course, is that the lower controller is inverted compared to the upper controller. And like most customers, when I first plugged in the SFPs, I plugged the lower ones in the wrong way up because they're a bit of a tricky fit, and mentally I thought they should be the other way up, but they didn't like going in the other way up.
Yeah, there are 2 tricks to that. One is that the bottom controller is literally a mirror invert of the top, and so not only do you have to flip your cables over, but port 1 is on the left on the top controller, it's on the far bottom right on the bottom controller, and so you just want to take note of that.
And then where are we going onwards? First time connection over the network, we're going to use the standard 0 config, so we need something that will work with serverless DNS.
Yep.
And typically, if it's a Windows machine, we install the Bonjour print services. This is very common for using the server-assigned IPs and initial configuration connection.
Yeah, in the field, when our systems engineers or our partners go out, if you're running a Mac laptop, then this is pretty straightforward because all the services are already built into the Mac. If you have a Windows laptop, you're going to want to install Bonjour. We, of course, are providing Avahi on board the controllers, and really you can do this with either C1 or C2, either controller, and there's an MDNS responder, and you basically just use a specific address that's tagged in the quick start guide with part of the serial number, and that will take you right to the controller and the initial setup.
So we're going to scroll down here, and it says the easiest way to do this is to plug a cable between your laptop and this controller, and this is the one thing you do before you leave after racking up.
Exactly.
And then I keep missing my mouse control is not great in here.
Jump scrolling.
So here's the important piece, is to work out the URL, and this does change based on the generation of controllers, so you need to make sure you have the quick start guide from the box that was shipped to you.
Yep.
And then you just form up this URL out of a prefix, which is Datrium-NS, For our units, it's the last 5 digits of that serial number,
Correct.
and then there's a suffix of -c1.local.
Yeah, pretty straightforward. Really, the only change there is in the newest version of hardware and software, we go use the entire serial number and just make that a bit easier. Of course, it's more stuff to type, so.
Yeah, and then we connect to HTTPS on that name. Now, the machine I'm currently RDP'd into doesn't have that connection direct to the zero config, so I'm just going to pop into my Windows 7 machine if I click the right icon. This Windows 7 machine is connected to that network.
Cool.
And I very happily took a photo of our
so
serial number.
Awesome.
So the last 5 digits are L7BET.
Yeah. And you'll note here too that really Alastair is doing this install, and it's not uncommon for our customers to do installs with our partner reseller there with them, or a Datrium systems engineer with them. It's really up to them. We are designing this to be as easy as possible, and we're constantly taking refinement. So even during the preparation for build day, we've taken a lot of notes about how else we could make this easy and what else we could do and what snags we might hit. If, for instance, we didn't have this quick start guide or maybe ignored it, what kinds of things would be more intuitive, to
Are
develop
you
this?
suggesting that I didn't actually follow the process?
Not at all, sir. Not at all.
And absolutely I didn't. I'm a good customer and I don't read the documentation.
Of course.
Because I like the whole idea of simplicity in product, but I did need to read the documentation to find this URL.
Yeah. And we do have a support portal, so basically when a customer becomes a customer and we ship systems out there, they have a support portal login, and that login allows them to jump into support. Of course, they have access not only to every single KB and the ability to create cases and request help, but also all the documentation is out there as well. And there's quite a book there. There's system management, there's hardware implementation. The Quick Start Guide is really your go-to to get yourself up off the ground.
All right, so here's our front page, and there's a standard password that comes from the factory, and that's documented in the Quick Start Guide. And away we go, log in. And it says, what are we doing? Are we joining an existing DVX? Well, if I'm following the Quick Start Guide, I probably don't have an existing DVX.
Yeah. And this branch here would really be germane to when we are adding another DVX data node to a cluster, because we can cluster up to 10 of them together. So if you had an existing implementation, that's where that question comes from, that I would just be merging. In this case, we're starting fresh with a brand new cluster.
And of course, when we say that, it goes through and sets up all of the master configurations rather than saying I need to read them from an existing DVX. Yeah. And that's why choosing that I'm going to create a new one isn't an immediate progress. It has to actually set up all of those pieces, which is happening now.
Cool.
And of course, this data node is the only part of the solution that has to be from Datrium.
That's true. Yeah, the data node is really the construct that provides the foundation. And so all of the software that we're going to install on the host is there. All aspects of the data resiliency and storage capacity is germane to that data node. And that concept of the off-host appliance was really born of the wish to be evolutionary beyond something like HCI, where I would distribute writes across host nodes. The hosts in this model do not have responsibility for data resiliency. That's the responsibility of the data node.
So it's that weird dichotomy of having a stateless host that does all of the I/O work and a stateful data node that is just essentially, as far as the I/O is concerned, is done.
Yes, exactly. The data node is the designated driver in the stack. It has all the responsibility.
All right, now the DVX has set itself up as the master in the new cluster. I need to log back in again using exactly the same password, and that's an interesting behavior, but it's understandable when we're doing a completely new configuration. And then seems to be some fairly self-explanatory questions.
It is, and we do really try to make this self-explanatory. In fact, I'm pretty sure that Juan Cesares, who leads the UI team, is probably watching with bated breath right now, very excited to see how this works for us.
But the documentation team will be really disappointed that I'm not going back and having to read the documentation again, because they put a lot of effort into it.
I think I'm just going to flip ahead in the book just so that we've got this handy.
You're going to catch up with where we are?
Yeah, that's a good idea.
So now we're ready to do the network configuration. We're already at page 13 of the build guide, and we've got a whole heap of network configuration in here.
Yeah. Part of this process of doing an implementation is to work with a customer and commit what we do is called a site survey. And so either the partner who is certified to deploy Datrium or the systems engineer, depending on the region, will send something to the customer and collect IP information that's specific to their network and their desires, and that will include all the data that we need for the management network as well as the data network for traversal. And so we've done that with Alastair and very much, of course, treated all our preparation for build day just like a real install. I've worked a lot with Michael McLaughlin, our Director of Tech Marketing, and then several of our systems engineers in the team to develop some of these practices and processes. And so he's part of that. He's with us here today. So basically, he is taking the part of our local IT admin and network administrator for vBrownBag, the company. And we've done this site survey, and we have all this information here.
And he's had a really fun day, as usual. The networking is the big challenge in setting this up, and we've had some frustration around the networking through the day, but through the week, but we now have a working configuration, and that seems fairly normal both for an IT implementation project. The server guys are frustrated by the network not working, and the networking team think that the server guys are not the smartest in the shed.
We have found that really almost every customer environment is different than the next, and so we wanted to be prepared for that case-by-case nature. And so as we train the systems engineers and indeed the partners, it is to say, look, the Datrium component of this is really very simple. Setting up the DVX data node, pushing the VIB to the host, all of that is relatively elementary, but you don't know what you're going to walk into. And that's why the site survey is so important and captures details about the entire environment, including the network and other characteristics as well. So it just really drives best practices approach and allows us to prepare for an install.
And we did approach this quite similarly to a real customer deployment, in that you and I and Mike had a call about 2 weeks ago where we discussed the existing IP and network configuration that I have. And during that call, you filled out some of the data on the spreadsheet with the IP addresses, and then you sent a copy to me, and I filled out a few more, and I sent them back. And I understand that then gets filed with support, that should I have an escalation at deployment time, you've already got that information. Yeah,
so our customer resource management stack, if you will, of course, is comprised of what's very common, obviously, Salesforce, and then that ties directly to our back-end support services. So when we file one of these, it gets tied to your account, and that way, if there are any cases that come up after that, we always have that quick reference to come back to, in addition to the contact list and location and what the hardware is, as well as the auto support information coming from that implementation, because we're doing auto support every 5 minutes as well.
Dial home, status reporting.
We have then this extra information, so that, and it's great because customers will often forget that we have that, and of course then they get online with support, and the support, 30 seconds later, tappity says, oh, so are you still on the 10.10. something, and then, oh yeah, exactly, and it makes it a lot easier. So.
All right, but we need to put these values out of the spreadsheet into the install wizard. So we needed, where's the install wizard gone?
This is where cut and paste is really handy.
It is, and I ignored it for too long, and it said, hey, you're going to have to start again. Too much conversation.
There you go.
So I'll just put those password back in, and then we will get to the network config. And we'll see if I can type the password 3 times correct. All right, I'm just going to progress through and cut and paste in here the values out of the spreadsheet, because that is by far the easiest way to do it. I don't need that new tab. I need the actual wizard. And I've just got to remember which key combinations to use. And
this is validation that we're live, folks, right here.
Yeah, my inability to type correctly is a great way to validate.
You are not watching. You're not watching pre-recorded content here.
Now we have a couple of floating IP addresses listed in here. What's that all about?
Yeah, so the architecture of the DVX data node is a dual controller. And that in and of itself is pretty obvious. We're using a floating management IP address that's used to address the data node. There's also a floating data IP address, and that's what communicates with the host side that are doing the compute. So you're putting in essentially hardware addresses that are physical to each controller, and then they're also putting in these floating IP addresses. And then the management floating IP address is also used later for things like setting up replication. And also, that's the network that's going to be routable to internet for the transmittal of auto supports. So we're doing 5-minute interval HTTPS auto supports, phone home, and then leveraging SMTP relay, which is a step we'll get to later, setting up the email relay here as well. But it really just drives the best practices around resiliency and fault tolerance across a dual controller design, that everything is redundant. We're using a methodology of auto multipathing that might be more defined as RPCLA, but it is that we won't have to do any special configuration at the switch for this. If there are multiple paths or if there's a multiple fabric present, our software will automatically find those paths and not only aggregate bandwidth for the sake of throughput, but it will also, of course, auto failover.
Oh, and when I change how the networking works, it wants to lose the values I've already entered. That's okay. And so we have a configuration where there's a, in production, we would use pairs of, I'm losing my mind here as I try and type these things.
Oh. Talking and putting in IP values at the same time, right?
So we have two 1 gig NICs that are used for management. In the lab, we haven't got a redundant configuration on those. We've got NIC 2 is connected to our external switch, and NIC 1 we're currently using for this zero config.
Yeah, 1 and 1.
And then we have a team configured for the SFP Plus ports.
Yeah, for our data transfer.
Now I'm going to go ahead and configure this network, because what we've found out is there's this timeout where it says if you wait for more than 10 minutes, it says you've configured the network wrong, it's broken, and so I'm going to fall back to the reconfigure state.
Exactly. So the intent of this is to say, if you had made some mistake and didn't get all the way through to where you had the management interface come up, or somehow forgot that, or something broke and you know your laptop went down or you ran out of battery, in a 10-minute timeout window, if you don't get all the way through network configuration commit, it will just revert back to the previous configuration and turn zeroconf back on. And so we actually start a clock timer to tell you that, and so you have a 10-minute countdown. So a little bit ominous, but you know, sort of like booking flights on the airlines. You're only going to get about 15 minutes before you lose those seats.
But if I'd misconfigured, if I'd set IP addresses that were in conflict and couldn't get into Manager,
go get a cup of coffee.
It's going to automatically fall back to it.
Come back, and then you'll be all set.
But I'm going to continue through to the user interface and log in again. And now I'm on the actual hard configured, well, now the floating IP address.
Yep.
And I'm going to commit the network change and say, yes, this is what I want. And that will stop the 10-minute timeout because I've successfully connected to the network.
Exactly. It's like defusing the bomb. Good job.
I cut the red wire when I should have cut the red wire.
Exactly. Now, the next step really just is automatically brought up in front of you. We're actually in the management interface now. And this is the final step where we're going to register the data node with vCenter. And so in most cases, we come into the customer's environment. They already have VMware and vCenter. We want to register that. And this is going to install our management framework plugin into vCenter proper. And you'll note that while we are on our own standalone UI, the vCenter implementation looks very similar to this. You can use either one of them. So this is the next step that we get into. And at this point, you would be able to really leave the data center and go back to your office and do everything else from there.
Yeah, we're doing this through the live production network. If you still had your laptop plugged into that auto support or the zero config network, you wouldn't be able to complete this phase.
Exactly, yeah, unless you design the management port differently and then maybe jockey the cable or something like that.
Yeah, there'd be that transition time. So I've entered as an administrator account in here. If I was doing this in production, I would have an account that is a Datrium DVX account in my vCenter with.
Don't we all just use root?
Lots of privileges.
We don't just. Sorry, I thought it must just be me. Mike is over in the corner grimacing as I log into the SE Lab as root all the time.
There we go. We're finished. Continue. We're ready to go.
Yeah. So we have just completed the base implementation of the data node. So the foundation basically is in place. The dashboard has come up, and that reflects to us that, there's a dormant data node sitting there, and we'll go and look at these functions later when we get kind of some co-pilot time as we've completed the install. But this is really the basis of setting this up, and at this point the customer could decide what servers they want to implement on and so on, but we've made this as simple as possible. We can now go take a look at this in vSphere.
So we've got all of these graphs in here which are not terribly interesting at this point because there's no workload, right?
Exactly.
So I'm going to pop back to my other machine, and we're a long way forward from the quick start guide in here. I need to log out of my vSphere client because there's a new plugin, and I'm not going to see that new plugin until I log back in again. And yes, use Windows session credentials.
There's a couple of steps that we'll come back to. The Quick Start Guide then references verification and additional DVX configuration. Now, obviously, it's important for us to establish the relationship with support. Because we plumbed the management IPs on a publicly routable network, auto support has already commenced. And so, in fact, the system has probably already sent kind of a hello to support. They would have received that, registered the system as online. We could further do a couple of things that some customers like to do, like I might send an auto support bundle. I'll usually do that after I'm up in vSphere. I can also go through and set up SMTP relay for email and things like that. We also like to go into CLI and give the customer kind of initial touch of what the CLI looks like, and then even trigger a failover back and forth between the nodes. And that validates that the network is in fact plumbed in symmetry, that we have the right ports and right port configuration, that the system, when it does a pre-check, validates that we can do failover back and forth between the two controllers.
Well, let's do that initial SSH connection into the floating management IP address that we configured before.
Sounds great.
I'll take that new certificate and log in as admin and that password that I just set. Oh, look at that, I've got a command line in here. So what are my tests?
So your verification and additional DVX configuration, basically there's a verify the gateway access to support server, so we can basically do a support connection test. So really the command you want to run is just support space test, and that will come back and give us a result in a minute.
Validate that it can talk to the support site.
Yep, exactly.
That makes sure that my DNS is correct and my gateway is correct.
Yeah, and tells us if HTTP connection is working.
Okay.
And we're true across the board, so that's great.
All passed.
Outstanding, nice job. So that's really the most of what we want to do there. You know, we can, if there's proxy server and things like that, you could set that up here. You could do that in the GUI or the CLI. The other thing that I would do here, this is really as much as we want to do in CLI here for the sake of the discussion today, but we can go through and verify floating IP addresses, remote systems, and this is really the node's failover. So we can basically ping the floating IP address from a remote system, in which case, you know, another server or something that we know is on that network, and that verifies that we've got that floating IP address up there and properly routed, you know, or in the case of VLANs and tagging and so on, that's working as expected.
Well, you know what? I haven't enabled SSH on my compute nodes, so...
Well, we can certainly come back to this later.
Yeah.
But we can, in the meantime, do node failover. And we do failover and fail back. But this is really basically just exercising the controller's failover methodology and going from the C1, which is what we start from, but default from the factory, over to C2, letting that come up, and then failing back over again.
So not listed in there, I think was a nodes list, wasn't there? Of nope, that wasn't the one. Nodes show. There we go.
Yeah.
I always like command line help when you mistype stuff.
Yeah.
So we can see that we've got our configurations all up.
Yep. And you can see our serial number and configuration stack. So, and obviously, if we had built out a multiple DVX cluster, nodes show would show up to 10 of these if we had a big cluster.
And I'm going to do a nodes failover. It says, "Are you sure you want to do this?"
Are you really sure? Yeah.
Yes, let's do that. And notice that at the moment, the prompt says that we're on node 1, controller 1. Of course, when it's failed over and I re-establish the SSH connection, what we should see is that it's on controller 2.
Yeah, exactly. The DVX data node is designed to run indefinitely on either controller. So even in a controller down situation, it'll run forever until you replace the other one. Same thing with upgrade procedures. Something that we probably wouldn't get to in a build day, but if, for instance, we're doing an upgrade, that's all automated through the UI. We'd come down, bring that code into the standby controller, roll it, have it reboot, come up on the new code, validate it, resynchronize the NVRAM cache between controllers, and then trigger a failover intentionally, and then upgrade the other controller, and then hold. So every time you do an upgrade, you're also exercising that failover, which means there's also a pre-check that won't let you proceed if the network isn't in fact configured correctly. And that's really handy. There's no way to really shoot yourself in the foot here by doing a failover as part of an upgrade, or even just doing a failover exercise. Some of our customers say, yeah, every quarter we do a failover on all of our hardware related to storage just to verify that it works correctly.
And this is an approach I really like, is to routinely do the hard thing.
Yeah.
Do the thing that sometimes causes problems, but do it so often that it never causes you a problem. And that follows the DevOps methodologies of keep doing things so often that you get good at them.
Yeah, sure.
Now that failover takes a little while because there's those pre-checks going on, and what I noticed as we were doing the previous dry runs on this is that it will this putty session will actually drop when the failover occurs. So it's just taking a moment to turn.
And it's the pre-work to do the failover, and then the failover itself is very quick. But obviously it's doing a lot of pre-check and then also preparing for the failover, setting up the other controller to be the master, and then it comes live. If you just walk up to the back of the thing and yank a controller out, the failover is pretty snappy because the other controller that's in standby mode has not only an vRAM image of everything that was in flight mirrored from the active controller, it's also in a full online and up state. So it's not as though we are booting the secondary controller from cold in the traditional active bypass or active stand. I mean, this is truly a standby mode, but the active controller is sustaining 100% of the workload.
It is taking a moment or three to do that.
So beyond that, what we'll see is setting up email alerts in the user interface. And so we'll go in and we'll make sure that we have the proper addresses in there. NTP time servers, pretty basic stuff. Configuring access to any proxies if we had it. In this case, we don't. And the rest is is pretty elementary for that initial setup. And then after that, we'll move on to actually committing in the compute nodes.
I might just duplicate this session and see if I log in again whether we're actually across onto the other node, and it's just that Putty hasn't noticed the change.
Sure. You could also pull up the user interface too and see what it's telling us.
Yeah, so the failover has occurred. We're now on controller 2 on that floating IP address. And so this connection to controller 1, there we go, we got the error in Putty to say it had failed. So we're now on controller 2 nice and successfully.
Great. Excellent. So we can go back to the web UI. There really isn't anything else that we would need to do at CLI at this point. So we can come back into our user interface, and this is where we initially would show the customer how to access that in vSphere. So we're just going to go to the home screen. You'll see a new Datrium icon there. Tap on that. That will take us to a very similar look and feel of the dashboard, just like the standalone UI. The reasoning for this is somewhat obvious. There really are two fundamental drivers for this. The first is that we have always intended to support multiple hyperdrivers, or hypervisors, I should say, and that obviously not all are built like ESX, so we don't necessarily have the benefit of something like vSphere everywhere, and so we wanted to have a standalone UI. This is also relevant in a failure mode or disaster mode. If I've lost vCenter because of significant outage at a primary site, I can access that floating IP address with Datrium Online and begin to reconstitute the environment, start restoring from snapshots, start recovering the environment, even at a replica site, without having to have this integration into vSphere. So really, as a standalone entity, it's a recovery methodology as well.
Great. And so here we have the user interface showing inside of vSphere client.
So a couple of things on orientation. First off, you see the big green check mark in the upper right.
I like the green check mark.
Yeah, that just kind of tells us right off everything is okay, and that's good. Yeah, we can take a breath and go, oh, look at that, everything's happy. Now, if you mouse over that and even click on that on the green check mark itself, this is not only a quick status update of things to see what's going on, this is also a navigation aid because, of course, any one of those things I can click on and hot link directly to what that item is or that area within the user interface. Now that we've got the data node online, great cue, by the way, it's like we practiced that, you now have a look-see physically at the data node itself, and we can see that all the disks are good. We can now visualize our network connectivity, the fact that the controllers and the batteries are up in a good state. And in fact, if I really wanted to have a look at this, scroll back up a little bit, and you'll see that there's a quick button there for a photo view. And that photo view will give us, again, just an immediate look at to what the hardware is with an overlay of the nomenclature of all the hardware. And we find that the customers really like this because this gives them the comfort of sending remote hands into the data center and touching the right thing because they have a physical depiction of it as well as the overlay of what it's logically named.
Working with an on-site operations team who have to look after every piece of hardware in the data center, it's really good to be able to see, to say, you see the purple port.
Yeah.
Exactly. Tell me what lights are shining. Make sure the cable is seated all the way in the left hand of the two purple ports at the top.
Precisely. And the typical tools are there. I can beacon this thing. I can do stuff to make it obvious as to which one. In a rack of 500 devices throughout the entire data center. I want to go to rack 13. Well, here's this thing. It's what it looks like. We make that as easy as possible. And the UI team is really focused on just absolute maturity, taking into account a lot of peril that we've seen in other solutions that we've all worked on, and has tried to make the customer experiences as shiny as possible.
It is all very nice. Now we've got some storage, we should really have something to consume that storage.
Indeed, I think that's a great idea. So the other thing that we want to draw attention to is the handy dandy gear icon. And the gear icon in most screens is up there at the upper right-hand side, and that gives us control to do some things. For sake of discussion, this is the basis of where you would trigger things like doing an upgrade. But you'll also note that we can do things like add additional data nodes from here. We can also add additional host nodes from here. And so in the case of our initial install, we want to go and discover in the cluster what host nodes are present that we want to then bring in and use as Datrium DVX compute nodes, which means we're going to find them and put software on them.
So we better actually get those compute nodes into the cluster.
That's a good idea. So we need some compute nodes to work with, and we've got 2 compute nodes in the rack. And so Alastair is going to access those. So you're getting both the kind of out-of-box experience of the data node, also of the compute nodes.
And these come from the factory with a build on them and are ready for us to do something useful with. Mm-hmm. So they already have, the Datrium compute nodes already have ESXi installed.
Yep.
And a fairly basic config on them. And I have to see whether how far Mike got in the middle of the night last night as he was rebuilding
doing our reset. So the Alastair's absolutely right. So basically what we're doing here is we are setting these up through a build process from factory that they show up at the customer site with ESX installed. In fact, Datrium software is deployed. They're ready to go. And of course, we're just using iDRAC for the initial configuration of these, and you can see the Datrium integration there and setting these up. Now, as we do find in a lot of customer environments, you have set up some intelligent pre-scripting for IP definitions and network configuration to make this easier. It doesn't have to be so, but in this case, for the sake of on-camera build day, very convenient.
Well, regular viewers of the build day will be used to me saying, I'll do it once by hand, but here's a PowerShell script when I have to do it more than once.
Yeah. I have learned that you are very much about the automation, and I sure appreciate that.
Oh yeah. It makes for a much more interesting build day, and also it's related to the fact that I get bored very easily.
Yeah.
And so doing manually the same process repeatedly is not something that brings me joy.
Yeah. And we have many customers that have come up and deployed 16 of these at a time or more. And so, in those realms, we do see customers using framework automation tools to push configurations to the servers and set up ESX. And there's no reason not to. I mean, you shouldn't have to set this stuff up manually one at a time.
And we want that consistency and repeatability on these. We want these compute nodes to be interchangeable and as close to disposable in terms of their build as you can get.
Right, because they truly are stateless in this configuration.
So let's see how we're going. We're just going through the initial boot. So while Mike and I were unboxing, I was concurrently, along with that, adding the compute nodes in. So now in vCenter, I have a DVX cluster in addition to my original nodes, and I've now got 2 additional ESX servers.
Yep, exactly. So really, this is kind of the state at which we find most of the customers' environments. Obviously, they have a fully grown out in production ESX cluster that's got servers in there. And so really the next step for us is to push our software to those servers. Really the only thing that predicates our software living on a server is that it's got at least 8 cores of CPU, that it's got a minimum of 800 gig of flash in it, and we need probably about 10 gigs of memory. Obviously most servers that we see in production, they're north of 128 gigs, maybe upwards of 512, half a terabyte. For us, really, our footprint is very small, so we're using the tiny vib architecture for the deployment of that vib. So once the servers are already up and we can see them and they're on the cluster, then we can go ahead and take that next step.
Of course, there's some networking required, and as I mentioned before, we cut to the video.
Yep.
I've got a PowerShell script which is now not going to run for me because I have forgotten some modifications to it. I modified it for my nodes instead of yours, so we need VMix 0 and 1 on this switch, not 2 and 3. So again, all of the proof points that we do this for real and live.
That's the thing. If we didn't have this stuff, people would think this is too easy.
So of course it's in invisibly small text inside my command window. I might just publish out this this PowerShell script that's here at some point.
That would be cool.
It really is just drawn from the add host script in my AutoLab. So that has all of the build automation pieces, and I just cut and pasted and modified a few lines in here.
Yeah.
It's not particularly rocket science script.
While that's working, it's kind of worth noting one of our significant verticals in our customer base are service providers. And so we see folks really leveraging the Datrium configuration into their automation procedures quite regularly. The CLI that we have really doubles as an API, and so you can leverage that for a number of different commands to automate things. But we find that that's really the one place where we see people deploying and redeploying and making significant configuration changes, or taking environments down and bringing them back up again. Much as we're doing here. So it's kind of nice to see what that looks like from our perspective and kind of lay hands on that in person.
Sure, and the important things that I've done in the PowerShell script is create some VM kernel ports. So I added a VM kernel port for vMotion and another one for IP storage.
Cool.
And it's that IP storage VM kernel port that we're going to use to access the DVX from these hosts.
Yep.
And I also created a bunch of virtual machine port groups and a couple of NFS data stores.
Great. Okay. So it really is kind of a mixed mode environment that we're dropping into.
Yes. So like a lot of customers, I use an NFS data store as a place to store templates and ISO files.
Yeah.
And that sits on some cheap storage.
Cheaper and cheap. Yeah. We in fact, that's a good point to mention too, in kind of our list of talking points, that when a customer looks at us after we've been deployed to the host, that's what we appear as, where we look and feel like an NFS data store. And so that emulation actually terminates in memory in the host. The back-end communication between the host and the data node itself is not NFS at all. So it's a proprietary methodology. That's our own technology at work there, and it's very agile. It's very low latency. But it makes it really easy on the hypervisor side that it just is NFS. And you can browse that just like you would any other NFS data store.
And NFS gives good visibility about the virtual machines and files inside rather than just being block.
Exactly.
It also, because of the way it's implemented inside the ESXi of the NFS stack, you can very easily get multipathing by having the same data store definition, but have it terminate inside each ESX server and get that inherent multipathing.
And it's also obviously really conducive to the beginnings of a log structured file system that we have developed here. Everything is a file construct, and everything is really based on an object store and containerization. So that's really kind of where that sets up and makes that easy for us then to develop VM queues and keep organization of data. And that ultimately drives localization. And the localization of where data lives is very important to how we cache intelligently, how we recache data, how we can do fast uploads from the data node into a host and things like that.
Because that localization isn't just the spatial localization of the data, as we'll see, is the flash inside the node provides the read performance. But it's also about localization of the data as it's laid out across, in our case, the spinning disks underneath.
Exactly.
Where sequential reads is a really important thing to be able to deliver.
Exactly. And really that even extends...
Let's get these hosts added in, because we'll have a moment or two while that's happening to discuss further.
Sure.
So popping back into the Datrium plugin and looking at our friendly gear icon again. As I recall, this is where I add hosts, not additional data nodes
that is correct.
Today.
Yeah.
I did try to do that the other day and got a little confused that I wasn't then offered a list of hosts.
Yeah. So these are the hosts that we have discovered, and we're going to pick which ones. Now, in this case, for sake of the build, we're going to start with the Datrium DVX compute nodes that we've supplied for this, and then we'll come back and we'll do your compute nodes later, and that's where we get a chance to really see how that's done in the command line interface, and why we're going to do it in the command line interface as well. We're going to get sneaky later.
So at this point, the thin vib is being deployed. So it's essentially pushing just a little agent to do the discovery of suitability for the next phases. Yeah, the tiny vib format is really very tidy, and then it just is going to come up there quickly and kind of begin to set up the framework of resources that we need to then have everything else upload into those hosts. And in this case, obviously, these hosts are completely dormant. There is no active workload on them. These are not true, and that's what we expect to see in the setup here. But
in a customer environment, we may be coming into blade servers, rack servers, a mix of those that are running real-world application load, and so we want to be completely non-disruptive, and that's really how the software is written, is that we can sneak right in there with the vib and set up our services and even grab the flash and grab CPU and have zero disruption to other applications that are running and other storage that might be associated with those hosts.
So I might have had a fiber channel or an iSCSI SAN configuration there, and then in preparation for this rollout, gone and added a couple of SSD devices to each of my hosts, one by one through the cluster.
Exactly, yeah.
And then at this point, I'm now deploying out, and those SSDs will be discovered, and we'll be choosing to use those.
Yeah, which is where we are now.
Well, look at that. Next phase has happened. So all the validation tests have been run, and the rest of the agent has been pushed out, and now we're being asked which of the storage inside the nodes do we want to use.
Now, this is interesting because this would be a little bit different if we were on a customer server, in that when we deploy our Datrium DVX compute nodes, they come pre-configured from the factory, auto-selected with the flash that's there, and this gives us basically a place to put our DA sys and then have our separate partitions for flash caching. So we have basically 3 flash entities within each of these hosts. 2 of them are for our read cache, and then 1 of them is basically for .sys, which is really where all the metadata reference repository is. This gives us some additional resiliency in that, you know, the way we're architected, we can lose flash with really no interruption. We can also even fail over and do reads from other hosts. That's called pure cache mode. We'll talk about that later in architecture. But it's all configured from the factory this way. If this were a customer host, I would see a list of flash that was there, and I would need to check the box next to the ones that I want. I would even be able to rescan if I had a host that could hot add flash. So you would see a similar screen later if I wanted to add flash to an existing host that was already within the DVX cluster.
And we'd do that if our workload was changing and we had a larger collection of virtual machines being deployed onto those hosts. And that might happen if we upgraded the RAM in the host as well, so it had more capacity to run VMs.
Yeah, sure.
All right, well, we take the defaults of grab all of the storage that's eligible, and we'll just go ahead and configure the hosts.
Yeah, I think that's a fair decision. Take all the flash. I think that's fair.
I think you've been saying earlier on, all of the flash is just a catchphrase, and we want, you know, deploy all of the flash into the nodes.
Exactly.
Because flashes these days, the grade of flash that we're putting into here is cheap. We're not buying it from a storage vendor who's marking it up by 90% or 900%.
Yeah, that is really a key message of what we're doing at Datrium. We are not in the business of selling flash. We are basically developing a solution that uses commodity flash very efficiently, but at scale it becomes really compelling in that in one host I can have as much as 16 terabytes of flash, or 10 flash entities.
You have to say 16 terabytes.
16 terabytes of flash. And then when you factor in deduplication and compression, which are real time in our solution, then you're actually looking at that probably looking more like an effective capacity of 64 terabytes or beyond. That can be any kind of flash. It can be any architecture. So that could be NVMe, it could be standard SSD, it could be PCI based in cards. We have basically a limit of 16 terabytes or 10 flash entities in a host, whichever comes first.
Right. And now the add of the nodes has occurred, add of the hosts. So if I pop into the hosts list, it'll show me the 2 hosts.
And I don't know if anybody was timing that, but typically it's about 90 seconds. And so that is a completely automated process that we put that stuff out there, grabbed the flash, started up services, and indeed presented the data store to both of those hosts. And there's really nothing else that you have to do beyond, you know, selecting those flash resources and saying go.
And of course, I love that I can see things here in the Datrium interface, but I'm a vSphere guy, so I'm going to convince my web client to respond again.
Yeah.
And the plugin works with the HTML5 client as well as the Flash client, but of course, when the HTML5 client isn't yet 100% feature complete, I always end up going back to the Flash client and wishing that the HTML5 client was complete.
Yeah, absolutely.
So I'm going to pop back into my hosts and clusters view. And what we should see is that my DVX cluster now has more data stores, and that we see, here we go, we'll sort them by capacity, and I have a 26 terabytes of capacity on my data store.
And of course, VMware accounts for this in TB bytes. For those of us that come from a SAN world, we would just kind of sling around the term, it's 30 terabytes. And really, that's as close as the similarities are to a SAN. It is a central repository where all the data goes, but it's really not doing any of the work. It is designed to be dense. What's interesting to customers and that they feed back to us a lot is, okay, it looks like a 26.4 TB data store, NFS data store, but then they start writing data to it, and of course, we are doing global deduplication across the entire cluster. So the more hosts that are attached to this, the higher dedupe tends to be down there in that repository, and so you'll see, anywhere from, let's say, 60 to maybe 160 terabytes stored in, a 2U chassis, all underneath the guise of a 26.4 TB data store. So it's something that you have to kind of get used to and sort of wrap your head around.
The provisioned and consumed and free don't all match up.
Exactly.
Because of that dedupe and compress.
And for that reason, we have we've gone to great lengths to make sure that it is incredibly intuitive and easy to understand within our overlay in the UI exactly how much capacity you've used physically, how much capacity that is in logical or effective deduped stuff, and then how much headroom you have based on predictions, based on the dedupe ratios that you're seeing. So we've really taken all the guesswork out of that we've made this as predictable as possible.
Nice, nice. And of course, now I've got a data store, one of the things we did want to do now that we've got some hosts connected was do the network.
Yep, test. And that gives us full validation to kind of make sure everything's there. So there's a command at CLI here too, and again, just being cognizant of folks that like to do stuff via CLI, and that's certainly me. I can go in here and actually do a network test at command line that will validate the entire data network. And we're a little ahead of ourselves that we did the full vib push out there and validated that we saw the data store, and that's just fine. You can always come back here and do a check and do a network test, and it will give you basically a full report to tell you if everything's in play.
And I tried to log on as root when I should have tried to log on as admin. There we go. While we're thinking about it as well, because Jeffrey just walked up and made me notice, we had a great tweet from William Hetrick, who's a real customer.
Yeah.
And he said he had to do a controller swap. So as we were discussing just before the hardware tour, he had to take out a controller. Presumably there was an issue with that controller.
Yeah.
And I imagine it was the active controller, because that's the way these things work.
Yep, sure.
Failover had to occur, and then new controller in.
Yep, we really appreciate him monitoring today. Yeah, I think he commented during the unboxing video that it really is just pretty simple. You pop the lock, slide the thing out, obviously after taking your cables out, and slide another one in there, and it is designed to just auto-absorb those resources and heal itself effectively. And clearly that's table stakes stuff of enterprise solutions today. But by no means is this anything super special. Yeah. But it's important that it is as easy as possible.
But it's that reassuring thing that the thing that should be simple is simple, and it's an appliance approach.
Yeah.
Where it just works.
Yeah.
So we're back inside the controller. Of course, we failed over, so controller 2 is the current active.
Yep.
And that was the network test, was it?
Yep. Network test, exactly.
And that goes out and does a series of tests. And what have we got? Hosts are okay. Data controllers are okay.
Yep.
And we have even all of our time server and everything looks good. We've got lots of OKs
and you can see here, obviously, this is kind of a reminder. We don't need a web proxy. We don't worry about that. We've only got one time server, but we haven't done our SMTP server, which means we don't have our relay set up for alerting. So now that we have the hosts online, that's usually kind of a logical good time in a customer install to say, okay, hey, let's go make sure that all the support stuff's working. We already did the heartbeat test earlier with a CLI command to validate that HTTPS is working. Now we want to come in and set our SMTP relay and
belt
and
and braces contact with support.
Yeah, exactly. The two protocols that we use for auto support are both SMTP relay and HTTPS, and so the two police each other. And so basically we'll go back to the UI at this point, and I'll show you where to set that up. As you might imagine, it's under the gear icon.
And inside the plugin.
Yeah.
And wait for it. Here it comes. Here we go. Hang on, it hasn't finished loading.
There you go. And so we're going to do configure DVX. Now, configure DVX is a catch-all to look at a bunch of different stuff. And again, this is where we've left the data center, we're coming back up to a comfy office somewhere, and this is the rest of the stuff that we might want to do. And this is where I would make changes for password and things like that as well. But what we want to establish is an SMTP relay. In fact, let's see, what one were we using the other day? Let me just pull that up for you.
Yeah, the trick is remembering that password that that you had.
I actually remember it, and it is kind of bizarre. It's not as clever as your secret password, but it's a pretty good one.
It was smtp.gmail.com, as I remember.
Yep.
And of course, that needs to be on TLS, and I can't remember the port number.
I'll find out for you in 1 second.
So I'm just digging that out.
And what I'm doing, just as a kind of a quick reference, because we're going to use our resources, is I'm just pulling up our systems engineering lab and taking a look at how we have ours configured. Sorry I didn't have that up already. Okay. And thank you, Mike.
Port and confirmation that I've remembered the username, and then Devin is going to enter the, assuming that I have got the user ID right.
Okay, let's see. Yeah, so our username is automation@datrium.com.
Oh, there we go.
And that was port 587.
Yeah, automation. And I will get you, Mike, to type your secret password.
I'll put it in here. I've got it. Let's try that. And I will, oh yeah, sorry. Natural way.
Yeah, my Mac's set up to scroll in the opposite direction to yours.
Natural, yeah. Okay, so let's just save that for a second. You wanted to type in...
yeah, let me...
put in an email address there as well.
Let's also have Alastair at vBrownBag .com notified as well. Cool. We'll save that.
Yep. And then you can run test mail from there as well.
Then we can
yeah,
test mail. So
yeah, you can crank in any email address that you want into test.
Oh, there we go. I didn't actually put myself. I didn't hit the add button.
Oh.
There's a classic Alastair.
Right, local context and global context, right.
So
cool.
Grab that. I'll add it, and I will also send myself a test message, and then save that change. And the test was successful, so we must have set the...
And you hit send, so yeah, so it sent you a test message. Great. So that means we've just validated the SMTP server, the port, the user account, the password, all that was good to go.
And I'm going to run that network test again to make sure that it's now giving me more tests, and it's now successfully talked to SMTP.
Yep, SMTP's there. Great.
So I've got 2 more tests succeeded.
Excellent. All right, so let's see, where are we on our build list? We've done the hosts, we've done config, mount of the data store. We are well into soup, Alastair. This is the part where we've kind of got everything tied together, and we know we've got a working solution.
So we've cooked the Datrium piece, and it's ready to consume.
Yep.
And of course, consuming means migrate some virtual machines on.
Exactly.
So let's take a look at my collection of virtual machines and start pushing something across.
Great.
How about we grab this Windows server here and just do a migrate. And I'm going to change both the host that it's running on and the storage that it resides on, because currently it's on local storage on my ESX server. And I'm going to push it out to host 5 in the cluster and the data store on our DVX.
And as folks are seeing here, this is really no different than any other storage migration. If they're moving a workload, we are capable of then just sustaining that workload. This is an on-the-fly change. There's really nothing disruptive here. Nothing has to go down. You're just doing vMotion. So really straightforward. And this is absolutely what we see most customers do. They're just going to pick a group of VMs and start to migrate those over. In some cases, they might have earmarked, some of their heavier workloads or some of the stuff that they are using for, test and development, or maybe a VDI workload or something that they're taking off of, some legacy concern.
Some underperforming storage that's leading to very poor user experiences.
Sure. Yeah, absolutely. And really, latency is key to this. One of the things that we're known for is having incredibly low latency because of that host-side caching. and because of the efficiency of CPU utilization.
And the key thing about it is that it's not a really limited size cache, so that there's a whole heap of cache misses that lead to really high latency.
Right, exactly.
And consequently, your 99th percentile latency is very close to your 50% latency.
Yeah, I mean, really,
it's a full copy.
Yeah, I mean, really, that is the intent, is to have everything run from cache all the time. And so you're sizing the cache appropriately to meet the needs of the thick provision size of your VMs, factoring in deduplication. There's a bit of factoring in how many cores you have. We've got a pretty simplified algorithm of kind of how to do sizing. And it's important to note, too, that sizing doesn't have to be done in any rigid way. If a customer says, boy, I'd just be more comfortable since flash is so cheap putting 8 terabytes of flash in this host, knock yourself out. There's no reason not to, other than your cost.
Yeah,
right?
and then knowing that over the lifetime of this host, I'm never going to need to come back and do that maintenance activity. Because particularly if you're a service provider, it's that return to the asset and make a change to the asset is the thing that kills your cost.
Yeah, yeah. And yet on the other end of the spectrum, for someone who's operating on a frugal budget and they're leveraging legacy servers that are a few years old, or maybe they're blade servers and they've only got a couple of slots, well then maybe you put two terabyte drives in there and not break the bank, and know that you've got more than enough to handle probably 20 to maybe 40 virtual machines depending on dedupe ratios. And if you need then to get access to more cache, you can always vMotion to another host that has more cache. So DRS comes into play. Other best practices for load balancing across the cluster become kind of obvious.
And how are we doing? Our first virtual machine is migrating across.
Very good.
And while we wait for that one, there was some more.
Yeah, can I show you a couple things in the UI while we're waiting for migration?
What else is interesting in here?
Yeah, so a couple of things that we do to kind of orient the customer to using this. Now, obviously, we're in vSphere, so this is just an overlay to vSphere, but it's really top to bottom visibility from the guest virtual machine all the way up to the cluster. So in terms of kind of identifying what this dashboard means to us, you can see that we've got some workload present now, which is just germane to this migration that you're doing. We can see some I/O, we can see some throughput, and latency characteristics. We're obviously not caching anything yet because we're just populating data in for the first time. Right, there's nothing going on there. You'll note, too, that we are looking at this in real time, and if I want, I could look at a 24-hour view and click into that. There are some things that become obviously more interesting when I've got some workload and it's been a couple of days. But we have an at-a-glance approach to this that without any significant drill down, I can see what's going on. So top line is really your performance and caching situation. If you scroll a bit, in the mid pane, you'll see that we can expand there. You see that more arrow right to your left there? Yes. This is really just our cache concerns. So this is giving us an immediate awareness of how much flash we have in the cluster. Later, I can drill down to the individual hosts, and I can look at flash in the host. But this is telling us how much is in the cluster, what we're seeing for deduplication ratio, compression ratio as we roll into it, and gives us a great understanding of how much we're using. Again, the intent is to always have the workloads live in flash, so we really strive to not ever have cache misses, and so there really isn't any behavior in our cache that ejects data from it. It is designed to run that the newest stuff is at the top, and the oldest stuff that's not being accessed is really kind of more overwritten. That's the very generalized way to think about it. Not necessarily FIFO, but akin to that. That really, when you promote something into flash, it's designed to stay resident there for a long time, and this gives you that visibility to understand, not only in real time, but also historically, how the flash is behaving and how the applications are consuming that space. If you scroll all the way to the bottom, that is representation of the data node and overall systemic resources. So on the left, you can see there that we're basically 100% free. We're just beginning to populate this. And now you can start to see what I referenced earlier, that we're breaking down what is the physical data usage here versus the projected. And as we start to see deduplication ramp, you will see these numbers kind of disaggregate or diverge, that you're going to have a very, very high top-line number, which is your effective projected capacity. But also, if you mouse over even that compression ratio, you'll find that the pop-up gives us a detailed statistic of LZ compression versus deduplication. Classically, deduplication, as it's known, is a hard task. It is something that requires a lot of compute. It's something that can take a lot of time. And in many instances, solutions have developed methodologies to do this in real time or post-process. In our mode, we are deduplicating and compressing everything in real time that hits flash, because that's facilitating a read cache that we want to be as efficient and as big as possible. What we are writing down to the data node is global deduplication across a namespace, And what we're doing is using a fingerprint architecture where fingerprints are applied to the data as it's being laid down on the data node, such that the data node doesn't have to do some massive processing to deduplicate the data. It simply has to do fingerprint comparison, which is a much, much smaller workload. And again, if you look at this chassis, it's a 2U box, a couple of controllers in the back. There's not a lot of cores in there. It doesn't have a lot of work that it does. So it's doing a constant 24/7 space reclamation process, looking for the ability to prune expired snapshots, find additional deduplication and compression and so on. But really, it kind of loafs along and doesn't have to do a whole heck of a lot. The data node isn't really responsible for performance in our stack.
And our first VM has migrated across, and I've started it up. And
cool.
This particular VM will start up a little benchmarking workload that I think runs continuously, and so that should generate a bit of workload. And I'm migrating another virtual machine in as well, and so what we should see is some more of this data being populated in here.
Very good.
But I think as the virtual machines migrate across, regular viewers of the build day will be familiar with the idea that this is not really fun to watch.
It's not drag race stuff, is what you're saying?
Yeah, well, what we're seeing is I/O going on. Now we're seeing some read I/O was going on in that moment as the VM was booting up. And if you happen to notice it, it was 100% cache hit rate.
Yeah.
Because we've got enough flash in the node to hold the entire machine. And so as it booted, it just read directly from the local SSD.
Yeah, exactly. Well, another step that might be interesting at this point, that we have some workload on board, I'm just kind of looking at our run list here. Once we have workload up and running and we've done everything related to support, really the next logical priority is the protection of the data that you're bringing into the DVX cluster. And that protection really is that our solution is designed to provide both primary storage as well as backup of all your data. Now, it's worth mentioning that we work with a very rich ecosystem of partnering technologies. And so while we provide a data backup methodology that's born of intelligent snapshot and very rich drive towards a catalog-based reference to even the files underneath VMs, there are things that we don't do. We're not providing, granular exchange mailbox recovery, right? That's not what this is for. So we have a great partner ecosystem with tools that do that. So we have partnerships in place with Kroll OnTrack or with Veeam. These are technologies that have feature sets that extend beyond our own, and in many cases, the customer already has licenses for. What we find is that we bring, I use this term, a betterment to them, because we can accelerate some of their processes and take those into Flash that might be born of disk in their default configurations. So I'll walk you through a little bit of how we would set up protection. Would that be okay?
Yeah, that sounds like a good thing to do.
All right, cool. So you see up in the top line, there's kind of a menu structure there, and on the far right is protection. So if you tap on that, that takes us into our protection dialog. And again, we're just within the UI inside of vSphere, so this is all very native and for the most part intuitive. And one of the things I hadn't mentioned yet is that the way our UI works is that anything that's labeled in green is a context-sensitive mouse over pop-up. So even if I wasn't here and you were doing this install all on your own, if you spend 30 minutes with the UI just literally poking around and just mousing over everything that you can mouse over, you kind of become an expert in this UI pretty quickly. And there's not a lot of stuff that you can break per se. So it's fully safe for you to poke around and try stuff and experiment. There's really no problem with that. So you can see here that we don't have any policies in place. And at the top, very logically, there's a capability to create a group. The construct that we're going to create is referred to as a protection group. And a protection group is not dissimilar to a backup policy in backup software. I'm going to identify a target of things that I want to protect. I'm going to identify a schedule, and I'm going to identify a retention depth of those. So why don't we go ahead and create one? All right. Now, I won't talk too much through this. I want you just to kind of poke through.
You know how well that ran last time.
Well, I don't know. I trust you.
Right.
I think why don't you just kind of poke through this and then ask me questions as you have them.
So I think since I'm setting this up at the beginning, I want to set up a lowest common denominator backup scheme that if I haven't thought things through, I'm going to get some useful backups of my systems that even for my least critical is going to be useful.
So that's a very interesting methodology, and I would almost call that like a catch-all, right?
Yeah, so I'm going to do a gold, silver, bronze. Well, I'm going to do a lead level of service called Plumium.
Cool. All right, very good.
VMs, I want this to catch every VM.
Right.
How about that?
There you go. So if you hit preview, There you go, because we've got
all one of my VMs.
All one. Now, I will say that as a basically as a global marker or as a global call out, because you're developing this policy with star in the search, this now means that any VM that comes into this clustered environment will now be included in this snapshot protection group here into infinity. And that is absolutely a catch-all. And we have customers that will set this up with, let's say, a naming convention. I'm from Seattle, so the servers in Seattle, I'll start with, SEA dash something, something, something. So if I wanted to create a catch-all that says, gosh, if I forget to go put something in a protection group, if I've built a server and it comes into the cluster and it's got a name that starts with this preamble, then I'm good. It's going to drop into at least my base policy.
That's the sort of lowest common denominator.
Yeah.
Let's just make sure that when somebody creates a VM and typos the machine name, and creates a machine called SAE, I'm still going to get some backup.
Get captured. That's great.
So no matter how foolish and careless I am, and as an administrator, I'm used to foolish and careless, and this is why we want to automate things rather than do it manually.
Sure, that totally makes sense.
But I can also select individual virtual machines and what
files.
Sort of files? Now we're talking about the files that are on the data store, not the files inside the VM.
Precisely, yeah. So we have visibility down to the files that are underneath the VM. So vDisks, VMDKs, VMX files, containers. In the case of other hypervisors, you would see containerization, or in persistent volumes in bare metal Linux and things like that. You would have the ability to select those individual object items, if you will. Right. And so you can also create a naming convention for those. So you can filter based on names or dot type or whatever it is that you want it to do, or you can manually individually select them. And so really, even within one protection group, I can develop a series selection of VMs based on name or individual selection, as well as files. And I could just as easily create a protection group that is just for files.
So one of the things I saw as we were looking in your lab is that I could specify a naming pattern in here of star.iso.
Yeah.
And almost no VM backups will back up my ISOs that are not currently connected to a virtual machine. Most of them won't even back those up.
Right.
Yet it's kind of important that I protect those ISOs, although they should only be transitory.
Yeah.
It can take quite a while to find and download all of those ISOs again if they get deleted.
That's true, and that's absolutely right, that we would find those and then include those within the snapshot backup. And so, really having that file selection criteria being really granular or global, I mean, it really is up to the user. You can create as many of these protection groups as you want.
Can I specify another pattern in here? Is it just comma-separated list?
I think it is.
Because I want my floppy images as well.
Yeah, well, we're going to find out. We'll find out and see, or see if we need to do that as a separate.
Yeah, I don't think I have any floppies, but am I good to go?
Yeah.
Yeah, we'll go continue on to the next
page. And that will
page.
Validate any selections that we made or any errors that we made. It would mark us up with red highlighting and let us know that.
Great, so I haven't mistyped.
Now, so at this point we're on a schedule set, and it's worthwhile knowing that we can nest multiple schedules together, and that those schedules by default have a minimum granularity of 30 minutes, and I can overlap multiple schedules so that I can get to something even more granular. If I wanted to do a 5-minute interval snapshot, I could absolutely do that. A lot of our customers will default to 30 minutes for the most critical things. They'll say, very typical stuff that you would see, hourlies, and then gold image dailies, or month end for finance backups and things like that. You could nest all of these together. So we'll start with one and pick whatever you'd like. Really, you can set these up.
Remember, this is my lead level of protection.
Sure.
So I'm going to do daily backups.
Sure.
And I want those to start at a little after midnight. I want maybe 2:15.
Yeah.
And if I'm only doing them once a day, I'm going to keep them for more than 4 hours.
Absolutely, yeah. You go as long as you want.
I better keep those for a month.
Cool.
No, a month's probably a bit long for this level. Let's go with keeping those for a week.
For a week, all right.
And I think for my lead level of service,
yeah,
that's going to be at my absolute dial tone. If you haven't been smart enough to make this apply to a better protection policy, then you'll at least get this much.
Sure. No, that's great. Yeah, so we can go ahead and press on with that and basically just keep that as a really simplified policy. And as we go next, then that puts that into place. We now have a protection group, and a relatively simple protection group as a catch-all that really is just kind of that brute force of like, hey, no matter what, at least this one's going to catch a backup for everything that's in the cluster. Now, why don't we go back in and create one that's just
I was going to
create
one for an actual service that I'm running. And let's call this the silver. Actually, let's do a gold level one.
Okay.
And I'm going to do everything that is a Windows machine, which should just still there we go. Our second VM has migrated.
Great. So we got another target.
So 2 VMs are migrated in. And I only want the virtual machines. I'm not worried about the slow changing ISOs because they'll be captured by my lead level. And that's the interesting thing, is that a single entity can match multiple of these groups and get multiple protections.
Absolutely, yeah. There's no blocking or isolation based on something being involved in one policy that it can't be involved in other. They're atomic. And that really drives, again, the ability for a lot of kind of refined best practices.
And I'm going to do a half hourly. This is gold, so it's going to be as aggressive as we can in a single schedule.
Great. Now, would you mind perhaps adding another schedule layer to that?
Yeah.
So this is really an ability to nest, and we can nest many, many different schedules in one policy.
I'm not keen on the idea of nesting here because these don't fit within one another. They run in parallel to one another. As
that's really a better terminology. Yeah. Within one protection group, you can create multiple parallel schedules and have them fire at different times, and indeed have them sustain different retention. Now, while we're not going into this in the build today specifically, this is also where I would set up replication. And so within
there's that little tick to say replicate
exactly, and the reason that we don't have access to that is because we don't have a replication cluster available to us. And so really the highlight of this is to say, within this same scheduling architecture and in this workflow, I'm setting up multiple schedules, different retention depths, as well as the ability to pick where I'm going to replicate, and that replication could be to any site that I have within the cluster. So if I can see another Datrium DVX cluster anywhere on the network, I can replicate to it, and indeed the topologies for many-to-one and one-to-many and bidirectional are all supported. In fact, even here, had we had it turned on, we would be able to select AWS and replicate into the cloud from here, just as simple as dropping down the box and picking that and then entering in our AWS credentials. So you've got multiple schedules here. Now, before you commit this, let's talk about our budget, because there's always a budget. There's always a piper to pay.
I got to pay something for this?
Yeah, on a Datrium DVX cluster, in our newest variant of code, we will support up to 2,000 snapshots per VM. In this version of code that we're on, 3.0 for our build, and that's just because that's literally what we're shipping today. So we wanted this to be very realistic to what's today. We have a budget of about 200 snaps per VM. So that literally just jumped by 10x, so we can go to 2,000. And our maximum budget for a cluster is 1.2 million snapshots. So
1.2 million.
1.2 million snapshots.
And that's on 2,000 per VM on the next code release that's not on this system.
Correct, exactly.
That would allow us 1.2 million, 2,000. That's about 600 virtual machines with a fully loaded 2,000 retained snapshots.
Yeah, exactly. And so the input from the customer has been a lot of information about how far they need this to scale, and if they really consider us their primary mode of data protection, how far do we need to retain that? Because
the really high numbers come from having a long retention, where this is replacing a push it to tape for my compliance copy.
Exactly. And so we do have customers that are absolutely using either the primary site or even a replica site as an archive location. And several customers pushing retention well out beyond a year. And then we still do see, the typical habits of destage to some kind of long-term cold media that's going to go into a vault storage somewhere, be that tape or magneto-optical, or even, incredibly high-density disk portable devices that then get taken out and vaulted. I mean, there's lots of different methodologies that we see today.
So let's calculate our math. We're doing 4 snapshots an hour retained for 4 hours, so there's 16 snaps in there. And then on my daily, I've got 28 days, so that gets us up to 44. And my weekly for 4 months, that's another 16. So I'm still only on 60 at the moment.
Yeah, we're well below the budgetary limit, even on this version of code.
Well, let's add a monthly that I'm going to retain. Monthly on, I actually like doing my monthlies on the 2nd, not the. I could do monthlies on multiple days.
Yes, you could. Nice. Absolutely.
And I'm going to retain for 12. Let's retain monthly for 2 years. That's another 24 snaps.
Yep. And really, too, what also factors into that budget is obviously the frequency of snaps. So we do have some customers that say, I snapshot every 30 minutes for, months. And that retention is that. So, when we get up into 2,000 per VM, you really have complete flexibility, because I mean that's more than most people need, especially when I say 1.2 million.
Well, so yeah, what I like is a platform where every platform has limits. I just want to know that in my normal operation I don't have to work around those limits. Those limits are bigger than is any sensible usage. So let's create that group of my gold level of service.
And that was just validated, so we didn't get any errors back, meaning that we're well below snapshot budget. There was nothing malformed. Everything was good. It does that check before as it commits, so we're good.
While we were watching that video and the migrations were progressing, we managed to capture one of the co-founders of Datrium as he was passing. Sazzala, Reddy, welcome to the vBrownBag Build Day with Datrium.
Thanks, Alastair. I'm happy to be here.
And Sazzala, the particular reason we wanted to capture you was that you were very much the architect of this data protection, VM protection that we did, and we set up some policies to protect some VMs, but I wanted to go through with you what the architecture was, the thinking and the philosophy around how that was set up, and particularly look a little under the covers.
Yeah, great. So previous to being a Datrium co-founder, I was the CTO of a company called Data Domain.
I think we know of that organization as well.
Yep. So, so I had a privilege and being lucky to meet a lot of customers in that while I was there. And what I found was that the backup and data protection seems to be a pain everybody faces. I
think everybody has a favorite backup product, and it's the one that they're about to deploy.
Yeah, that's right. I think so before Data Domain, there was tape. It was even worse than that. So Data Domain made the pain easy from that angle, but still backup remains a big pain. And having studied that for a long time, so we had some interesting ideas, and having personally experienced and people's pain. And if you ever met any backup administrators, they'll tell you how
they have less here than I
have. They feel the pain every day. So we're like, okay, how do we kind of make this change? And also, there is a transition to cloud. There is a transition to having less budgets, and mostly the roles are converging, and there's no longer this multiple people doing multiple things. There's one person generally trying to do everything.
But at the same time, as you're getting less people, you're getting much more aggressive recovery time and recovery. Data loss windows are being squeezed and squeezed.
That's right. And if you have like a 1 petabyte of data, it's no longer that easy to move the data and back up somewhere else.
Bulk copies become
it's just hard. And then if you really have a disaster and you're trying to recover all that stuff, it just becomes unmanageably hard to do all this. So we thought, let's just do it differently. And given the background we have, and I think we kind of understand the pain, and we have felt the pain from previous experience. We said, okay, let's just do something different and better for the customers.
Let's continue to build on what we've already developed and build something better.
Right. And then the other thing to notice is that you must think of, in a storage industry is like, I mean, if you look at the architectures, if you don't build something from the beginning, if you have not thought about it, it's very hard to retrofit. So that's why I think from the beginning, we had the goal to tackle data protection early on. So we have built foundationally from day one, how are we going to do this? So it's not a new thing we suddenly started, but it's built into the system from day one.
And the same as the data efficiency features of dedupe and compression. Bolting those on afterwards is a nightmare. But
that's right, exactly.
Building them in and having them as almost an immutable part, you can't turn them off.
You can't turn them off.
So
exactly. So if
you can leverage them.
That's right. So if you see any vendor having a knob to turn off something, it means it doesn't work very well. Like Data Domain had dedupe on. There's no turning off. Pure, for example, has no knobs to turn off dedupe. So if anybody has a knob, my experience has been that marketing wanted that knob, and that's for a checkbox, and they added that later on, and it basically is off by default because it doesn't work well. So to avoid all those problems, we thought really deeply about it. We invested a lot of our effort. We have a good team to go and build the foundation of data efficiency, because there's a foundation, and then layer things on top of it.
Yeah, great. So let's have a look at.
You got
some slides to show us?
Yeah, I got a couple of slides. This is the picture which probably you've seen before. Most companies.
The sea of complexity.
Yeah, right. And this is surprisingly how a lot of people do have the setup. Like they have the VM servers, they have the SAN for storage, primary copy, and they have a SAN switch to manage, and then there is the backup software to manage, and then there is the proxy servers, and then there is the backup boxes. Another bunch of disks to manage.
Now the secondary copies?
Secondary copies. And then you have to have then WAN replication because you want to do DRs protection somewhere. And you replicate the whole thing on the other side. Ultimately, if you look at the number of boxes, number of people you need to manage, it's like there are 3 people to manage all this stuff. And there's multiple UIs to manage, multiple things to learn from you. And ultimately, what we found is that Dell did a study on this and said about like a big chunk of this much of like complexity makes recovery actually harder. you actually lose because you can't know what you did, what you didn't do, and then it becomes really hard to do this. So the question we had was, if you look at the slide, what if we remove all this? What if we remove all of these pieces and made it quite simple? Like, what's stopping us from doing this, right? What's stopping us from doing the unified, a unified way of managing this?
Build it into the core product rather than a series of bolt-ons.
Yeah, it is a bolt-ons, right? Right. So why not just do this? Because it is a hard project, but if you spend the time on it, if you think of the customer's perspective, then you can do this. It's possible, and we have demonstrated we can do this. So the question, is that why should we do this, right? I mean, I just explained the complexity, but there's some other truths about it. Like, it's not just backup; it's the long-term archiving. There is now the cloud backup, and there's encryption. There's other policies. There's DR. I mean, it's not just backup; it's the other data management. It all falls under the data it's a wider picture, right?
Yeah, the use of copies of primary data for test and dev and user acceptance and e-discovery and all of those.
All of that stuff. Like, how do we make it really good and really easy to use? And if there's only one administrator or one type of administrator, can they all use it without having to learn complex stuff? How do you make it all? And how do you also present this as a usable, simple interface, right? So that's the thing to think about. And so what are the driving forces for unification? I'm calling it unification or convergence. You can call it both. It's economics, number one. It's the cost and the ease of management and basically the less maintenance. You don't have to maintain, upgrade all of these systems.
Separately,
you have to kind of...
But with interdependencies between which ones you can upgrade when, and
exactly.
You get into the dependency help.
And when one of them doesn't work with the other one, they have to call up support and okay, this doesn't work. Okay, they have to triage it. But if you had like a unification, there's convenience in that, right? Ultimately, there's a cost and there's maintenance hassle, and then there's convenience. Like, how convenient is it for me as an administrator that I can do my other job, which is to manage the apps, manage the business. I don't want to manage hardware anymore. I want to manage the business. So it's a convenience, pure one interface, easy to use. It just simplifies everybody's life. Today we are in the world of consumer UI. I mean, like, why are we still stuck in the past, right?
Why is this harder than my iPad?
Right. Yeah. Exactly. Right. So, and then the other question is, okay, we have made the case for why we should unify. The question is, why now? Why wasn't it happen before? Like, why is it that we can take this challenge now? So the important thing to notice is that VMware changed everything. To be so honest, virtualization, but VMware is a big proponent. See, before VMware, there were all these esoteric, hardware, like AS400, IBM mainframe, and you had all these other things, and Solaris something. So you needed a heterogeneous way of being backup. And there was no easy way to do this. I mean, the incumbents had a strong strength in that because they knew all this hardware topologies and
that have agents for each of the various operating systems.
So it's very hard, right? It's very hard to enter that market and do all this stuff because you no longer, I mean, it's very hard. It's a very hard science.
And it's all fragmented.
It's all fragmented. So, but with VMware, what has changed is if you just back up, if you understand what VMs are, and if you can just back up VMs, you've done 80% of the job, right? There are some things
we're not replacing the application level backups, as Devin and I discussed earlier, but the fundamentals
are there.
The whole VM back.
It's an easier bar to get to, and with VMware and virtualization being here, it becomes much easier job to do that. That's why there are a lot of new entrants in the market, like Veeam, for example. By the way, Veeam has just crossed revenue of Commvaults. It says something.
So they exceeded Commvault. They've been in the market for, what, 30 odd years?
Yeah, exactly.
Wow.
So maybe not 30, maybe 20 plus. And Veeam is a new entrant, only does VMs.
Only does virtualization backup.
And they have taken over Commvault. I mean, Commvault is legacy. I mean, yes, it is true. Some people have AS400, IBM, whatever.
For those
people, sounds great. But Veeam has, I mean, I'm telling you that the virtualization has made all of this easier. So once you understand what a VM is, then the next thing is that you can build primary storage specifically just for VM awareness, right? So that's the new entrance you see, like hyper-converged people and like us. We understand what VMs are fully. And then once you know how to do what VMs are, you can do primary storage with VMs, provide higher level conceptual simplicity. And the next thing you can do, if you can do that well, is like us, build in backup. Because then you know what VMs are and you can do primary storage. Because the VMs live on you, then you can just make backup just much easier. So the question then is, okay, we made the next case for why now. What does it take to do primary plus backup? Like, what do you need to do? First thing you need to do is understand VMs as first-class objects. You need to know what the VMs are. You need to provide VM-based policies to have a protection policies. And you need to make it easy you need to build some of the backup features other backup vendors have. There's a reason they have those features, like single file recovery, like object level recovery, those kind of things you need to build. And ultimately, you need the easy button. It's got to be easy. If it's more complicated.
Yeah, that's the easy button, simplifying everything, making it, removing all of the complex interdependencies is the big trend in the last 2 years.
Yes, exactly. So I mean, you set up policies and you forget about it. Right? That's what you want to do. Just forget about it and then just move on. So the question is then, why can't SANs do this? Like, why can't like regular Nimble or Pure or somebody? Why can't they do this too? I mean, they have snapshots. Why can't they do this? It's very hard for them because they don't know what a little VM is. They only know LUNs. Who wants to back up LUNs? I mean, doesn't apply, it doesn't map to your business.
Yeah, the granularity of policy needs to align back to the business requirements for the workload.
Right. So, and LUNs don't map to the business requirement. They're an artifact of some old 30-year-old.
You can make them.
You can make them,
but that's another thing that you have to manage, is that mapping of this collection of VMs have to live on this LUN because this LUN has this replication schedule and this backup. Yes.
Actually, I don't even think you can map that easily. I think you can try to, but I think most people
I've seen the spreadsheets. You can do it, but you don't want to.
Yeah, exactly. So that's going to become a harder thing to do. And also then let's say they figure out some way to do this, then you need the next layer of efficiency. You need global dedupe. You need to use hard drives. If you do all flash, you cannot still not cost competitive to do backup. I mean, there is these issues, right? And not everybody has global dedupe in their architecture. And more importantly, what I found is that these are all technical reasons. These are all like fun, but more importantly, it's a mental problem. Is that you need to have empathy for the end user. Like you need to think about the backup admin problem. So a lot of people, I mean, I'm not saying negative about them. It's just that have you been there before? Have you understood the problems the IT administrators have? Like they're solving one part of the puzzle, like storing primary storage, but have they understood the whole data management aspects of it? It comes from experience and just having some empathy for the end users. If you go to the data center, don't just talk to the primary storage guy talk to the other people in the team, and you'll need it. So you know that there is a pain everybody has. So it comes from that basically fundamentally. Technologies anybody can build. It's did you understand the problem that's facing in the entire data center, right? So what did we do to solve this? Like, what did we do? So we have unified it. We make a very simple system, very easy to use. It's converging compute. Compute also is another thing. Hyperconverge, right? Why is it successful? Because they're making it easy. They're converging a few things. We took the next step of converging even backup. So compute, primary storage, backup, and disaster recovery, and backup to the cloud. And all of these things, you can call one phone call, you can solve all of it, and it seamlessly works with all of these pieces. It's well integrated, well tested, and you have a single interface, very easy to use. We've really worked hard on making the interface easy to use. And we have a small footprint. You don't have to manage lots of stuff.
Lots of different devices.
Right, and we're very efficient. Cost efficiency is very, very good with us. And that makes it actually legit. Like it makes it actually possible, cost effective to do all this stuff. And so again, going back to the legacy, there are so many pieces involved. There's CPU cost everywhere. You have to have the backup proxies and all those things. And then you need multiple drives and catalog. So we took all of that and said, okay, how do we converge all of that into our system? And if you want to do a good job of trying to say that you need to, sorry, this slide. I have a few slides. ESXi is the same thing. Yes, they've solved some problems, but still the backup remains to be a challenge for them too. I think ESXi, one issue is that it's built with 3 copies because each node is kind of separate. And if a node goes down, you need another copy. So then they do erasure coding is hard unless you build from beginning. Again, it's one more thing. Erasure coding you must build from scratch from beginning. Otherwise, it's really hard to bolt on. So if you have 3 copies of data and dedupe doesn't really work well, then how do you have like lots of copies of backups?
Lots of backups.
Yeah, then it kind of becomes expensive. Then you have to buy another backup system because you have to. There's no choice.
Or you're just buying more capacity.
You're buying more capacity, right? I mean, and that becomes a challenge then. Sorry, I have a few. Okay, so back to this one. Oh, all right. So the secret sauce. What is our secret sauce in doing all this stuff? So we have a scale-out software controller, which is kind of does it all. So it does inline erasure coding, inline dedupe and compression, all those things with the encryption on. So we made it really work well with a really high performance. So that's number one goal. Number one goal is that if our primary storage doesn't work well, what have we done, right?
Yep.
Then we're just a backup vendor.
Second goal. First goal is always return the data that was stored.
Oh yeah, sure. I think that's a given. So we have really worked hard on making sure that we have all the checksums, end-to-end checksums. We scrub the data all the time.
But performance and that distributed controller through all of the compute nodes.
Right. So we recently published an industry benchmark from IOMark because we wanted an industry validation, not some homegrown, some FIO thing. We have those too, but we wanted an industry validation. So we have beat other benchmarks by 10x. So, and to just prove that it is actually works the way we said it works, and with no knobs,
nothing to tune.
Nothing to tune. It just works. And so very high performance, very high ingest rates. And the next thing is we have all the data reduction, which really helps with the doing the backup kind of features. And we have encryption, as you know, already talked about it. So then how did we do data? How did we do data management? How do we do data management in our system? So we know what VMs are. So but the problem with LUNs was that you don't know what they map to, what's inside of it. But the good news about LUNs was that there are a couple of good points, though. I mean, it's hard to say what good points are, but I have come up with 2 good points to say about them. One is that there are less of them.
Yes.
Like there are less of them.
You can container for multiple VMs.
Right. You can click on a few of them and set policies. It's possible. The other good thing about them is that when you take a snapshot of a LUN, all the VMs in there get snapshot together. So if you want consistency, right? So if you have a multiple VMs, sometimes you have multiple VMs. You have a database 1, you have a web server, all that stuff. If you do backups, like one by one, they come with different points in time. So when you try to recover, what did you get? You got all these different things.
Which point in time did you recover to?
Yeah, exactly. And you got different things at different times, and how do you put it together? So I never understood that. But LUNs, the good news about them is that if you put all the VMs in the same LUN, if you manage to, then you can snapshot that LUN and you end up at the point in time. That's the good news about them. But if you go back to the VMs again, like the problem with VMs is that if you have lots of VMs, hundreds and thousands of VMs, right? These days, you can't click on every VM to set policies.
It's not a human scale.
It's not a human scale, and then you're like, and then you hate your life. You're like, you're back to the problem. Okay, I'm managing too many things. Like, so we've done some innovation on that. Like, how do we scale? How do we manage set policies at scale? And how do you do consistent snapshots, right? And then once you have done that at scale, then you also want to drill down. Like, how do I? Once I've taken all this high-level view. When recovering, I want fine-grained recovery.
Very detailed.
You want very detailed recovery, and you want to be able to find those things. And once you have a million objects of snapshots, how do you find these things? Like I have thousands of VMs. I took millions of snapshots. How do I find my objects, and how do I operate on them? That becomes the next problem. And then, so what we decided was, okay, so in generally VMware, there's the live data store, right? There is the VM store or live data store, which is where the VMware wants to project. You want to see all the VMs. But we built another a database called SnapStore, appropriately named for
holding
snapshots. We built a separate database. It's really fast. It's a kind of in-memory database, but it's of course it's on disk too. But it's an in-memory database where the queries are really fast. Like they're like nanosecond, millisecond kind of latencies. So all the policies are held there. All the global policies you set, and also all the snapshot metadata is held there. The underlying data architecture is all shared data, yes, but the database
there's one dedupe store underneath and two ways of accessing it.
Right, 2 views, like you mentioned before. There's 2 views to view it. Each one has its own way of looking at the live has its own way of looking at it, and then the Snap Store has its own way of looking at the data, and then it has a little bit more database properties to like query things and fast accesses. But you also made sure that we kind of spent time on making sure that if your live VMs are down, it's a P0 escalation. If your backups are down, it's a P2 escalation kind of thing. So we tried to make sure that that there is no interference between the live and the backup. So that also one must think about it, like from a customer end customer point of view. Just because you did snapshots now, is it affecting my primary storage? So we tried really hard not to have that. We kind of separated them out so that there's no interference between those two views. Then from a policy perspective, what we have done is that we have something called protection groups. It's not a new name; it's a common name. We didn't come up with a better name than this. So what you can do is that you can make a few policies. You can say gold, and you can say gold, I want the policy to include all my SQL servers and my web servers. So there could be many. So you can, most people have naming conventions. So it's very easy to set up, okay, SQL star. It means it'll pick up anything, any VM with that SQL as a naming convention, or your web server star, and then it'll pick up all those names. You can also pick individual ones if you care to, but you can just set up these policies, and automatically, dynamically, we will figure out on the fly the change of these.
If a new VM is created that matches the pattern.
Exactly. Or if the VM is deleted, it'll just delete it. It'll remove it from the list. And then, so when we snapshot them, for example, you can say star. Star means everything. You can have 6,000 VMs. We will snap them all together at one shot with no performance impact to anything. You'll see it's a glitchless snapshot.
Because it's the underlying
deduplicated
storage system, and it's just a metadata.
It's metadata
pointer that's been
metadata point in time. Yeah. So the advantage is that you don't have to worry about, is it going to impact is it going to stun my VMs, or is it a performance impact?
And that allows you to do continuous backups through the workday, through production, which of course now is 24/7 anyway.
Exactly. In fact, our QA, because we have millions of snapshots, it takes a long time to test. Like, and if you really think about it, if I set a policy for a daily and then have a million, it'll take a million days. So how do you make this faster? How do you test this? Right, have a QA. So what we have is, internally we have 1-minute snapshots. You can take 1-minute snapshots. The UI exposes 5-minute snapshots or 10-minute snapshots at the minimum, but you can go down below that and then say 1-minute snapshots. So our QA folks they have 6,000 VMs. They set 1-minute snapshot policies because it's faster to test.
Yes.
Like, the policies faster. Not always, but sometimes they do this because it's convenient.
So that'll be around 1,500 snaps a day per VM to get to your million snaps.
That's right. So I mean, you gotta expedite this, right? So that's kind of what we have done, is that you can take snaps as many as you want. There's a limit, 1 million, because we had to put a limit because for testing. Otherwise, you say infinite. I don't know what that means. How do you test this, right? So we decided to keep a number. I think 1 million is pretty good so far. So that's kind of what we try to do, is make it easy and make it effortless and not think about it. There's no stun times. There's no need to worry about any
no impact to operation.
And because of the architecture we have, the dedupe and the data nodes, it's very cost efficient. You can just scale. You have more snapshots. You want to keep more backups. We have customers now who want to keep 4-year backups. They want to keep 4-year archives. Okay, go for it. Because they want to keep daily snapshots.
That's all of their long retentions.
That's right. And you can have hundreds of VMs, thousands of VMs. It doesn't matter. You don't have to think about, like, I have to click only 200 VMs in my policies now. Just star. You can do it.
And those policies are both local snaps, but also replication to a remote DVX environment.
So when you set up these policies, you can also say, every hour you take a snap, but every other hour you replicate to the other side too, and you can have different retention on the other side. And because we have global dedupe end to end, what I found is that not many people have global dedupe end to end. So it's interesting. So the reason it's advantageous is because if you have multiple VMs, sometimes you have the same data. A lot of times
you often have the same operating system,
right? Exactly.
Same patches.
That's right. So no matter how it ended up there, you can have multiple sites replicating to the main central hub. No matter how the data has come, right, you end up negotiating with the other side, saying, "Do you have this?" And yes, I have. Most probably they have it, and then you don't have to send all this data.
So if I've got lots of branch offices, they've likely got the same databases being sent down, and so we're only going to have to send back to. Actually, they probably came from HQ, so we don't even need to send a copy back.
That's right. We also done other interesting things, like some of our workflow things, like you can click on a VM and say, "Send this one time to another place," like just replicate it. Because I'm trying to, like, if you have a remote data center, remote office, and then you want to just seed it. You can just send this one-time thing.
Send a snapshot, and then later I'm going to migrate the live VM, and there'll be far less data to move at that point.
That's right.
Nice.
And the other thing is that it's not just VMs in your business applications. Sometimes it's also the ISOs and OVAs. So we also have the policies, and in a policy you can not only just pick VMs, you can also pick like other objects in your system. Because what about those? Who backs them up, right? And you did all this. Sometimes you have a golden image. Where did it come from?
It's funny you mention that, because that was a policy that I set up. Devin and I set up a lead level protection for my environment, which is the lowest common denominator, and it included ISOs and floppy images, but I missed OVA files.
Right.
Yeah. But that's all backed up infrequently in my environment just as a lowest level catch-all.
Right. Actually, by the way, you can set up a policy to replicate them every minute, but then if nothing changed, it will send nothing. Right.
And it affects my budget of a million snaps. So,
yeah, sure. That's probably fair. And then for replication, so we have topologies. It scales quite well because we've done the replication a little differently because we have host-based architecture. We use the power of the servers. Each one has a little bit, but then together.
This comes back to we have a storage controller in every one of our ESX servers, and it's the storage controller that does the replication, not the disk shelf.
Not the disk shelf, exactly. And it's coming from local flash generally, all those replications.
Of course, because it's a read access that comes out of the flash.
It's very fast. If you really have a local LAN, it's super fast. If you have a WAN, we have some settings. You can throttle the settings, and you can say, okay, I'll replicate only this bit. And we have a good system of alerting you, like if something is falling behind, we'll tell you what's happening. And those are the kind of things we have done.
We're not making our policy compliance, because that's the other thing is policy-based management means you don't have to look at the logs of the successes. You only have to be alerted for the failure to comply with policy.
Exactly. Like if you said replicate every 1 hour, but then it's falling behind because of the wire. I mean, the network is too slow, whatever, or too much change rate. Because you want to know, because you have to tell your other application people, your database.
It's a business risk.
Business risk that it's not happening. Then either you need to change the pipes to be faster, or you need to do something to make it. So we kind of make sure that we don't tell you success, we don't tell you like failure, so that you kind of not alerted too often. Who wants to get our emails every day, so.
I'd like one a day telling me everything is good and I can go back home at 9:30 in the morning because all my job's already done because I'm only the backup administrator.
I asked the question to customers and they said, I don't want to know anything. I just want to know if something has gone wrong. So, so the next thing we have right now is that sometimes some people don't have a second data center because the CIO said, I don't want to pay for a second data center. It's only for DR, but all these expenses, I'm buying all this legacy architecture, like, primary storage and backup servers, everything again in the data center, or to put people to manage it.
And we only turn it on once a year when we do a DR test.
Exactly. So we're like, why do this? And also I met another customer recently who said they have DR offsite replication to Houston and Florida. Both of them got wiped out. He's like, I need to do something about this. So we are now offering a cloud backup offering. So basically, think of what is our product just offered there. It's seamless. It's managed service. Like you don't have to do anything other than your credit card. You need a credit card to charge, of course. It's not free.
Because you're gonna need some storage somewhere.
Yeah, that's right. So when you set it up, it's like when you set up a replication to another system. It's the same. It's that easy. You set up the same way policies to replicate to our cloud backup offering. It's a managed service. It means that we will take care of managing it. Like if it goes down, we'll bring it up, we'll upgrade it, so that you don't have to worry about managing it. So basically, it removes it's like a SaaS application. It removes your burden on you to do all this stuff. All you need to do is just set it up, and then all you need to do is decide that you want this, and it just works for you. And because as you know, public cloud is not cheap. So global dedupe is important.
It is. Right?
You can't just send fools once in a while anymore.
It's you're paying for capacity every month.
Capacity, yes, exactly.
And transfers out.
Transfers out. And so the typical way backup software do this is they do fulls once in a while, and they do incrementals, right? So the problem with fulls once in a while, incrementals for us, let's say weekly fulls, right? That all is ending up there and is eating up all the space over there. If you have tape, maybe it's okay, but for tape, there's no choice. There's no choice.
No cloud tape service.
There is no choice like that, right? So you need to do this in the cloud. So without global dedupe, with basically multiple VMs getting there, you don't get the savings. If you do fulls and incrementals, then every once in a while fulls, you don't get the savings. So you need to figure out how this is going to work. So what we have done is that we have end-to-end global dedupe, the same way it works. We have incrementals only forever. And the other thing is that once you have something there, you want to search for things. So we have a global search. You can, on your on-prem box, you have something. You can search through here locally. You can also search globally and say, okay.
So you have the full catalog of the replicated data on your local.
We query. No, it's not like that a little bit, but we kind of query. We kind of capture some information and so it's easy to query.
Right.
The queries are fast.
And I was just thinking, it's not even an incremental forever. It's a unique data incremental forever.
That's right. It's unique incremental data forever. That's right. But when I say incremental forever, what I mean is that
we don't do a periodic full.
Right. And let's say, and then there actually is quite interesting use cases for global dedupe. Like people say, it's technology, but no, actually there's some use cases. For example, if you are starting off with like having a 100 terabytes of data in your local on-prem. To start the seeding, if you want to seed that data, it takes forever. Like it took forever. So we'll at some point offer a service where you can just, Amazon has a snowball service, you can just package it up. So if you package it up and send it there and you just dump it into the cloud offering, it doesn't matter how it's dumped there. It'll next time then you start seeding, it'll detect everything's already there, and then don't have to send all this data over again. So there's some other advantage of global dedupe. And the other not talked about much advantage of global dedupe is because the way we do it is content addressable system. Like how did you know that what you sent actually ended up there? Like blockchain. So we have kind of like blockchain in the sense that we can determine that what we believe we got and we got.
But yeah, you can do a reverse validation. The data stored matches the address that it should be stored at.
That's right. So we check data at least once or twice a day to make sure that everything is self-consistent. And I believe, and also when replicating some other place, before saying we did it, we check it to say that it's fully what we believe it should be, because otherwise you don't know. So
and that plays really nicely into the discussion that I had with Lakshmi that we will play out around the single drive failure and latent sector faults, that you do need to do that validation regularly.
Right. So then the next thing is, okay, why do people do backups? It's for recovery, ultimately. They want
I don't want to do backups, but I desperately need to do recoveries.
That's right. So then when you do recovery, then the things you care about are the big disaster like recovery. Like the whole box has gone down.
Smoking hole.
That's an easy one. The whole thing has to come up. We already have that feature in our product. But then next question is, okay, it's not that. Somebody deleted a file.
Foolish user.
Yeah, or somebody deleted a VM by mistake, or they did something wrong, and then they just go back. They just need to go back in time a little bit. So for that, they need VM level granular recovery. They also need object level recovery because I deleted my email. I mean, one email box, one email has disappeared because I deleted it. I got to get that object level recovery. And that was the purchase
order for a $500,000 order, so I really need that email back.
Yeah, exactly, right? So then you need to make that convenient for the end user to like be able to recover these smaller objects. So we've done multiple things for that. So this is, again, if you want to do backup, you must do these things so that you are fully like making the life easy for the end user. Not just snapshots. You got to think of the other things they do.
Full cycle, yes.
Full cycle, yeah. The full cycle data management, like, So, so we do VM level recovery, which is sometimes just need useful, and we do VMDK. The next level is VMDK level recovery because sometimes your VMDK is messed up. And we also have partnered with Kroll. We'll do more with them in the future. But right now we have partnered with Kroll to do exchange level recovery, single email exchanges. And they also provide support for SharePoint.
SharePoint and SQL?
And SQL.
Nice. So that's hitting the big three Microsoft apps. And,
right.
Active Directory as well, or not yet?
Active Directory, I think, not sure about that one yet. So the other one is single file recovery, which gets asked a lot quite often.
Yes.
But and I think we have all the tools to build it. We'll soon expose it. It's coming. I'm disclosing something which is coming in the future, near future.
All statements about future are subject to change.
That's right. That's true. But we're working on it actively. So that's the. So ultimately, what this helps you is that if you have a unified architecture, you can have many systems in your across the data centers that replicate to each other or replicate to the cloud. It looks like one pane of glass to manage all your VMs and the entire life cycle of that VM. So it makes it convenient, makes the life easier to manage. It makes your life easier on a day-to-day basis. You can just go home, not worry about all these pieces working together, and one phone call to call, there's a problem. It just makes it all convenient for everybody.
One of the other really nice things about the Datrium architecture is it's API first. So although I can do all of these things through the GUI, if I'm a service provider that needs to integrate with a self-provisioning portal, it can all be done through APIs.
That's right. So all our system management functions, like all the functions we provide in the UI, they're all done through APIs. Like the APIs are all uniformly well done, so that we thought about future-proofing them. Some of our engineers have come from like established places, so they kind of have been through the cycle before. So we kind of all know.
Yes.
We're not discovering from first principles again all these issues. So that's the kind of where we are. We want to make life easy, unified, simple, and it just makes everything just convenient.
Excellent. Right.
So that's all. That's the story of Datrium data protection.
Well, thank you very much, Sazzala, for spending some time to dig pretty deeply into what's going on and how and why. I'm trying to think, that we have another resource about data protection. We're going to look at the results of the protection we set up on some virtual machines. And so, yeah, thank you very much for joining us. Thank you very much,
Alastair.
We're going to switch you out and switch back in the blue shirted Devin.
Okay, awesome.
Thanks very much.
Thanks very much. All right, Devin.
And now the data migrations have been progressing really nicely along as I've been talking with Sazzala. So a bunch of virtual machines are now there. My ESX service, the vBrownBag mobile lab, is nearly ready to be evacuated. So the next thing we will do is clean that up, so delete off the data stores and get ready to add it into the DVX cluster. I think that's probably the thing I want to do at this point. So I'm just cleaning up the leftovers. vApps you can't migrate from one data store to another. You can only move from one cluster to another. So I've cloned my vApps because, of course, they are absolutely clonable objects. So I'm just cleaning off the last things that are left. And I guess I should start up those vApps also on the DVX cluster.
Great.
There we go.
And add to our workload a bit there.
Yeah, the dashboard's going to be much more interesting if I've got a bunch of VMs running in there.
Yeah, sure.
The other thing I should do is clean up the data stores on my ESX servers, because the installer for the hyperdriver isn't going to be happy to see existing data stores, is it?
Sure, right, yeah, exactly. We're going to want to basically pull those in and use them with ours. Now, really, ultimately, it's not going to matter. So if you have other stuff sitting there on a server that's legacy, you can totally choose to leave that there. It's not going to be a problem. We're going to present our own data store independent of that, and there's really no interaction between them. So kind of up to you. You know, if it's tidier to sort of not cross the streams, then I certainly advocate for that. But really, no problem for us at all.
So I only have 2 SSDs inside my ESX servers, and so to have that redundancy of storing, what was that core that you?
There's the .sys, which is basically our metadata reference, and then there's the file stores themselves. And yeah, basically, if we're going to implement a host into the Datrium cluster, there's a requirement that we have a minimum of 800 gig of flash on that server. And we want that to be across 2 drives, which means that your minimum flash drive size is 400 gig. And we want 2 of them in there. There's some resiliency that we've built in, which means we can fail over, we can lose a flash drive. There's no interruption there. In fact, even if we do lose the last flash drive in a host, that's when we get into what we refer to as peer cache mode that we talked about earlier, where we can, in fact, sort of in an emergency mode, reach across and handle reads from a neighbor's cache. And so that's a survivability methodology until you can get in there and replace those flash drives. Works pretty slick. But in standard procedure, these servers that we're going to bring in here today really represent what we would see in a customer environment. They're different than the Datrium compute nodes. They're not uniform to our configuration. And what we see at a customer site is all of the above. They're x86 compute. It's blades. It's racks. It's different brands of servers, different ages of servers, and those are all absolutely subject to use. Fundamentally, this is what we really see as the significant deviation away from HCI. And as one of the points that we find answering to customers a lot is, how is this different than HCI? That's really it. We don't require any symmetry. We can use any kind of server. There's no requirement that the cluster has to be similar really in any way. As long as it meets the minimum requirements for resources and it's on at least 10 gig Ethernet, it's useful as a Datrium compute node. We're not distributing writes across them in any way, which means that the cache is used exclusively for reads and only ever used for reads. So when we write, the enablement that the data node really provides us, and being kind of the foundation at the bottom of the stack, is that I'm not write buffering into flash ever. I'm only ever staging data into flash in anticipation of reads. I'm committing writes into NVRAM architecture within the data node, and that again renders my host stateless, which means that the host can be anything. So that's what we're going to kind of example here. And we have a video of the write path. We talked with Boris Weissman, one of the other founders, and spent just on 20 minutes talking about the I/O path and the writes.
it looks like we're not going to have to wait long enough in the live event to play that video.
Cool.
So watch for it in the playlist that comes with this build day. It's really interesting to see how that write path behaves and see how all of the coalescing of I/O and that NVRAM buffering to get full stripe writes that are specific to a particular virtual machine.
Yeah.
So you get there's some really cool stuff in there.
Yeah. As well, Keith Townsend from CTO Advisor, of course, has done a number of interviews this week while we've been here doing setup, and there's some great kind of why we did stuff from some of the founders and executives as well.
Yeah, because he did interviews with yourself and with Hugo Patterson, one of the other founders and the current director of engineering, is it?
CTO and VP of engineering, in fact. Yeah.
So yeah, that's some really good content, as well as talking with the CEO and another of the founders, Brian Biles, around more of the business-oriented piece and the financials, and that, of course, is the key value for working with Keith and CTO advisors.
Yeah.
We're down here in the engineering, but somebody's got to pay the bill, and Keith's content is really good for helping that person along.
Sure.
So here we're back in the console. We can see a few thousand IOPS going on, a bit of I/O, 100%. Cache hit ratio for the reads, so we're looking pretty good. Yeah. But now I want to add 2 more nodes.
Yeah, that's great. So non-disruptive process, we want to kind of show something that is interesting, that's a bit of a detection here. So as you go through and you select these other nodes and design to incorporate them in, we're running a series of pre-checks on those nodes, and we're going to go through and try to validate whether or not they're going to be useful and meet minimum requirements. And so part of that process is to look at number of cores. Well, your servers represent what we oftentimes will see in the customer environment, that there are newer servers and then there are older servers, or there's the production environment and lab environment, and things like that.
Or there's a split configuration that maybe we had a cluster of lower performance hosts that are used for maybe a Devin test environment, not a full-on production, and maybe there's some up-spec things for running our database applications, and maybe in the middle there's a soft center where there's the general purpose virtualization cluster.
Yeah, exactly. So in that, we really do believe, kind of at a philosophical level, that our technology should be able to be used across all of the above. And with that, we know that as those servers differ, there may be different performance. And so a customer has an opportunity to really stratify and kind of even tier that they can have VMs live where they need to based on the merits of those servers. So if I have a brand new faster server and it's got 24 cores, I'm going to put my busiest latency intolerant applications there. If I've got older lab servers that are 3, 4, or 5 years old, I'm going to put the cheap and deep applications on there that are more maybe capacity centric and don't need performance.
And things like my antivirus servers and my build server and all of those utility machines that we and IS like. Yeah. Now, if we come back to the screen of my laptop, we can see that
we see some red. We see some red.
We didn't really, we weren't surprised to see red when we got to here, because we knew that the test was going to want 8 cores, and the vBrownBag traveling lab is quite small. It has to fit in that checked baggage size and weight, and so I've only got 6 cores.
Exactly. Now, we mentioned very early on in the discussion that we have the site survey, and part of the site survey does talk about the hosts and how many cores you have and so on. So we collect that information, and we can advise the customer ahead of time to say, hey, by the way, there's some minimums. However, that doesn't preclude us from using these, because we have another methodology at the CLI level where we can effectively bypass this requirement and say, let's go ahead and insert them anyway, because we're old and wise and we know what we're doing. So we'll go ahead and bring them in.
Yeah, so we're going to cancel out of doing this in the GUI, and I'm going to pop into, what command lines have I already got? Well, I'll grab myself host 1, shall I?
And what we're going to do here is just refer to
that's whether I haven't turned on SSH. So let me just pop back into those machines and enable the SSH while you fill for me.
So we're going to basically do what's called just a vCenterless implementation. So we're going to use our command line interface to target those compute nodes of yours and push the vib to them, and then start that up. And of course, we will get some messages and talk back in the CLI with that same pre-check, but it will allow us to go ahead and do this, not even as a force, but just a, hey, do you want to do this? Yeah, go ahead, and then we'll bring those in.
So I'm just turning on SSH, or at least starting SSH. I'm not going to need to leave it running. I only need to get connected, and of course, because it's installing the drivers in user mode, I don't even need to restart the hosts when we do this, which I was fairly impressed with.
Yeah, we really don't have any restart or interruption to the host at all. Really, as long as Flash is already installed in that guest host, there's nothing that's going to take it offline.
So here's my host 1 ESX server, and now there is a KB article on the support side about how to do this.
Yeah.
But I recklessly didn't search for it, but I did retain the steps.
You remember the steps. Okay, yeah. So there's two ways to do this. You could pull up the command line interface guide, which is one of our run books, or you could just use the KB article. In this case, I had sent you the KB articles that you've got that in reference, and you've kind of cached what those commands are. So we have that present. And any of these documents would be accessible via the support side if you're a customer.
So there's the sequence is to install that thin vib, which actually the test used the thin vib, so the thin vib's already installed.
Yep.
And it ran this, this local CLI is what's provided by that thin vib. And so it runs this check, and it's this check that is going to fail because I don't have the 8 cores. And it takes a moment to run. It says, yes, first test, you don't have the 8 cores we need, only 6.
Yep, exactly.
And that's what the GUI has run and stopped on. So I'm not going to let it stop me. I'm going to say go and start and connect to the data floating IP address. And there it is. All right, service has started. Although it's returned and said it started, the reality is it's still sitting somewhere in the background. And the DA command, DA command is there.
It's going to run, And you know, really, depending on how your SSH is set up, if you're doing this in CLI, and of course I know folks monitoring and looking at this later, you know, everybody has their favorite terminal and their favorite practices for accessing a CLI. You might need a session restart. There's a couple of things that can come in there and blip, but you're not restarting anything on the host itself.
So while we run, I'm going to do in parallel the 2 hosts.
Cool. And
that helps us to fill in the time.
Yeah.
And the next command we really want to do is this one, the DACLI, which is in the SSD show.
Yeah.
Now, we don't really need to show the SSDs other than to validate that there are SSDs available.
Yeah.
But if we wanted to be selective, we could choose which ones to add.
Absolutely, we could. And you could even do that at CLI level. You know, here in this case, we have the capability to pick any SSD that's there. And obviously, we always want 2 to be running for resiliency, even though we're not using them in a mirrored pair or anything. There's no error correction or erasure coding or anything like that across them. We use the entire capacity of the flash because it's only ever a copy of the data that we know is also on the data node. And so there's really no danger in not doing that.
It's still just a cache. It's not the primary copy of the data that we require.
Exactly.
So I'm going to add all of my SSDs.
Great. Which is a general rule. Add all the SSDs.
Add all the SSDs. And while it's adding on host 1, I'm going to go across to host 2. And of course, I don't need to list my SSDs on there because I know it has the same ones.
Yeah.
So this, there we go.
Yeah.
Didn't run the DA script first.
The other part of this that we're doing now is really referred to as split provisioning. So what we've just done is committed the addition of host compute nodes without doing anything at the data node level. We haven't added another data node. There's no requirement to. That is a capacity pool. It's plenty big enough for our production purposes now for vBrownBag and for this build day. And so I can continue to add hosts. And in fact, one data node could support up to 32 attached hosts, and they could all be dissimilar from each other. I could have different amounts of flash in each one. I could have different architectures of CPU, different architectures of flash, blades, racks, doesn't matter. Right. That, again, is obviously a departure from, from HCI. That the open converge, the open nature of this is that I can add servers of any value that I want to. What's important to kind of recognize in sizing is that every server has potential. A 2 to 3 year old server that we would see in a standard customer environment that they might consider kind of legacy is still probably capable of a good 35,000 IOP all day long if the application's there to push it. Brand new servers, it's not unusual to see 75,000, 100,000 IOP, again, if the application's there to push it. So we've sort of removed speed from the question to just say it's probably going to be really fast, even if it's a couple-year-old server, because you're doing reads from flash, because you're using CPU to do all the I/O processing, and that's even with all data services on.
And one of the sort of philosophies in this, why that test, the GUI test, says you got less than 8 CPUs, I ain't running, is because in order to get the best performance, you need ample CPU time available.
Yeah.
And of course, with less cores, you have less.
Yeah.
But my storage only needs to be faster than my workload.
Right.
If I've got less CPU cores, my workload is probably going to run a little slower. Have a lower demand, I should say.
Yeah.
And then it doesn't matter that I'm not running the fastest that I could on top of this DVX. I'm still going to run faster than I would have otherwise.
Exactly. Yeah.
So we've got the drives have been added, and so the final step is to actually mount the data store. That's again a one-liner, and of course, with some little checks in there, we could probably throw this all into a single script that runs on my ESX service.
Yeah, and we definitely do see that within our service provider customers and large enterprise that as they frequently are adding servers or changing server configurations, yeah, they will script all of this out.
Now, that big rack of gear that we've got in there, the black rack, is something that you guys call a POC avoidance kit or
a pack. A pack, yeah. Should I share a little bit about that?
Yeah, let's talk a little about that while we're waiting for the data store to mount.
Yeah, we're very much in the business of proving ourselves as an emerging technology company. We understand there's a lot of solutions out there. There's a lot of noise, and we want to differentiate ourselves and really provide customer validation and get that advocacy from the customer by giving them a great experience. The logistics of something like this, where it's a disaggregated solution that involves perhaps their hosts and our data node, or our hosts and data node, to give them that experience, the pack makes this really easy to do. So a customer can actually work with their local Datrium sales team or their reseller, and they can request that a pack comes on site. So in the case of a customer that says, hey, look, I really need to try this to validate this before I move forward with a purchase, but I don't have any place to install gear, or I'm in a production environment, I need to be standalone and isolated, we'll just bring in a pack. And it's
all of my servers are in a colo. Can you give me something that I can wheel into?
Yeah, so we basically have like a quarter rack that wheels in. It's not light. I mean, it's not a one-person carry item, but we ship it to site, and the customer can implement it. They can put anything on it that they want. We reset the whole thing when it's done, and those kind of travel around the nation. Normally, we run a standard POC process. So if a customer comes to us and says, hey, I've got a project, budget has been established, I believe that your technology is a fit for what I'm doing, then we would bring in a truly brand new production-built data node and potentially compute nodes, and then they would buy those.
And yeah, conventionally that'd be off the back of a conditional PO. That if there's a successful POC, then you send an invoice and they pay it.
Precisely.
But what I understand is there's been some experience of these packs going out, and it's a fixed time, normally about a week-long engagement.
Yeah, kind of funny about that. So there's a limited number of packs, and so the teams move them around pretty aggressively because they are lightweight, they are agile, and they're designed to be that way. So we refresh them back at corporate, we flatten everything off of them, and of course there are commands the customer can run to erase their data, and we have kind of military-grade capabilities there. So there's no concern with that, with the packs floating around, but at the other end of that, we'll set a limit of 5 days, and then that Friday we come around to pick that thing up, and we've had some gnashing of teeth and great resistance to let them go after they've had a chance to use them. And we've seen similar effect where a couple of customers have moved application workloads to the pack, and not exactly against the rules, but I mean, obviously within
it's exactly what you tell them not to do.
Yeah, I mean, we're telling them, hey, this is, use test workloads and so on. But we have had some anecdotes of folks coming from different departments saying, what did you do? Like, how is everything so fast and so snappy?
Because Will was talking about the local SE here in Silicon Valley was talking about going to a customer, and the finance director turned up next to the IT director's desk and said, what have you done? And the IT director's going, oh God.
Oh, this is a true story. So we actually had a deployed solution in a customer pretty recently where the primary workload migrated over the course of a weekend. And when everybody came to work Monday, the IT director was there, and he came in looking at the infrastructure, everything's solid, it's good to go. I think it was VP of Finance rolled in mid-morning, and kind of had a head of steam on, and he didn't really know what to expect, and he said, so what changed over the weekend? What did you do? And of course, just immediate, dread.
Red face.
Yeah, just red face, just draining, complete dread. And he said, we migrated workloads over to the new infrastructure components, and that's Datrium, and
that's that
we
PO
added some
that
servers. Yeah, that PO. And he said, it's amazing. Everybody in finance is talking about how fast the application's running, and everybody's saying that the database is way faster than they've ever seen it before. And it was like, oh, okay, holy cow! Great job.
Warm feeling comes back.
Yeah, exactly. But and we've heard other anecdotes like that, and you love to have advocacy stories like that, because it does build a fanatical customer base. And we hear that kind of stuff frequently, and that's a good weather vane that you're doing the right thing, you're in the right direction, but it also validates that, hey, you know, it's kind of a no-brainer. Host-side compute, host-side flash caching, these are important. Even HCI moved the ball tremendously far down the field in, you know, consolidating workloads and developing convergence, and we are just the next evolutionary step beyond that to add that openness and that freedom of choice back into the equation to avoid lock-in. Somebody could just as easily vMotion off of us as onto us, and we recognize that.
In fact, I do that.
Yeah,
as we're tearing the system down, I had to bring everything back off, and it was just storage vMotion's off.
Yeah.
So while we've been chatting about that, the add has completed on both nodes, and so what we should see if we come back into the vSphere client is that my hosts can now see, we've got data stores view, and there's my vBrownBag data store 1, which is my 26 terabytes of storage, and that should mean that if I drop my hosts into the cluster, because coincidentally they have the right kind of CPUs and all the network configuration is right. As long as the vSphere client is behaving, let's try that one more time. I should be able to move them into the cluster. And of course this is what customers would do, is take their existing hosts and add them to any new hosts and form up a cluster. Something's gotten confused in the web client, but host number 1 is in. Pop in host number 2, and now my cluster has expanded. And there it is. If I pop in on the summary tab, we should see lots of storage.
That's great.
A very light load of CPU and memory, because really we've got, what, 116 gigahertz of CPU time and just under half a terabyte of RAM across those machines.
That's not too bad.
We've got a bit of capacity to run some workload.
I've seen us deploy into quad-core environments. I've seen us deploy into 6 and 8. I mean, it's really there's really no peril there. We're never going to have a hard reservation that blocks anything that VMware is doing. We're typically never using more than 20% of available idle CPU. We know from stats that we go and investigate that the average customer is probably 15 to 25% CPU utilized in a typical vCenter environment with a typical ESX host. So we're going to come in with our VIB and grab by default 20% of that CPU, just the idle, and produce I/O with that and do data services around dedupe and compression and even encryption. So obviously, the more cores, the faster it has the potential for, but lesser cores is okay.
And I saw there was in one of the validations, there was a check that you could build a 1.6 gig RAM disk. So I'm guessing that's about the RAM footprint for this?
Yep, absolutely, yeah. And really, if you kind of tally up the entire memory footprint, again, we're very transparent about this. The software needs about 7.5 gigs to run on a given host. We then need, approximately for every terabyte of flash that we're managing, we need about 2.5 gigs of RAM. Right. So it's pretty simple math. 2.5 gigs of RAM per terabyte of physical flash that you have in, not the logical flash. And that's all we need for the metadata reference repository.
Great. Well, now we've got our cluster, our host.
This is great.
Everything's up and running.
So why don't we take a look at the Datrium aspect of this from within our UI segment, and that will give us kind of a good look into, if we go to host view, our list of hosts there, and of course we can kind of see how those are represented now that we've grown that list a bit.
And hopefully we've got a bunch of I/O going on as well. Moderate amount of I/O going on. Nice iset rate. If we hit our hosts, we can see some flash actually in use.
This is great. This is great. So this is kind of neat. We just finished looking at this from the CLI perspective. Why don't you click on one of those hosts and let's drill down a little bit and show you what we can see at a granular host level.
So if I go in here, it's a context that's going to take me to the host summary in vSphere.
Yep, exactly. Actually, the Datrium view of that, but also within the context within vSphere that I could pop right out of it. And so now you've got this capability to really kind of jump in and out of these. So what I want to get to is really looking at a Datrium host in the Datrium interface and determining how much flash is there. And so if you look at what our view is of this, we can actually drill down and look and have representation of individual flash drives as well as the active VMs that are on this host. So if you click on flash there for a second, that'll take us right in. And one of the things that's neat about the user interface is that there are several views that commence a trend graph the moment that you drop into them. This is one of them. So you're seeing about a 5-minute window across those statistics that you see represented under the two flash drives.
I'm switch hosts because this is one I've just added, and there's probably no VMs actually running
yeah,
on it.
it's not doing a lot.
So
sure.
I'll grab one of your hosts that came in the pack with it.
Yeah, there we go.
There we go. We got something much more interesting going on
perfect.
here.
Yeah, so 2 things to note. Right off the bat, we're running in insane mode. And that is a default condition for fun. We have this capability to run in fast mode or insane mode. We've already switched this one into insane mode as part of some of the pre-work that we've done. You can run as a customer in either mode, and by default, the customers would run in fast mode. Fast mode uses 20% of CPU. It's a moderate mode, if you will. It still produces a ton of I/O. In fact, one of these Datrium compute nodes, even in fast mode, is probably around 45 to 50,000 IOP capable. If I punch up to insane mode and the application's there to drive it, I can double that workload. You'll also see latency decrease. You'll see queue depth decrease on that host.
So because we're dedicating more CPU to, well,
precisely
allocating more CPU.
And really, you're unlocking further the true I/O potential that the flash drives have that are in this host on that 64-bit bus path. That they have an incredibly low latency characteristic. Typically, flash latencies, even with commodity flash, are around 50 to 70 microseconds at the bus. If we add back VMware's inherent latency at the hypervisor level that none of us can do anything about, and it's really not a big deal, we typically do see that reads are always around 200 microseconds at the guest VM, that writes have a round-trip acknowledgement latency of around 700 microseconds to get down to the data node and back again. So you really have both accountability as well as agility in that I can see this stuff, but also there's really nothing in the way. So this is dissimilar from a SAN architecture where every write and every read is going down the wire to a box at the end of the wire.
And they're all funneling into a very limited number of storage controllers and the inherent queues and CPUs in those storage controllers. And we've seen the heat maps on a dual controller storage array where the hard drives are all looking green to amber, but the storage controllers are all solid red.
Yeah, maxed out, exactly, And that's something that's interesting too, just as an anecdote to the more technically inclined that are watching today. We have had customers that have come to us and said, I've got an adequate server for this, but I'm running like 80% workload. Like, can I use DVX here? Is that safe? And it turns out that if you go look at ESX top at a CLI level and you monitor for CPU ready as a stat, if CPU ready is running really high, that usually is a direct indication that you have high latency to some storage, some legacy storage. If you reduce that latency at the data store level for the VMs, you'll see queue depth go down. You'll actually see CPU utilization on a VMware host go down. And so oftentimes when we come into a customer environment and we get that initial migration done and the workloads migrate, they'll see CPU load on those servers go down.
Because storage latencies dropped out and all of the I/O wait time in guest goes away.
Exactly, and that is a big eye-opening experience for a lot of customers that really validates, okay, this is truly like different than what I've done before.
Yeah, and we also see that with situations where you move from spinning Rust to SSD or Flash. I mean, it's partly that all of those reads are coming from Flash, but also all of the writes are going to vRAM. So everything is a sub-millisecond typically.
And we do account for this really using D-average and G-average. So we're actually looking at this from the perspective of what the VM itself sees, what the guest application sees. And that was something that for me, I came from a SAN background, where I thought I understood what speed was, looking up into the network. And I knew what my turnaround rates were coming from Flash or hybrid approach down there in the controller, but I really had no idea what was happening up in the host and
indeed the transition all the way through into the VM.
And there's a lot to account for there. There's a lot in that stack. And so we, being both pitcher and catcher in this equation, right? Because we are a front-end file system as a construct running in, a hyperdriver mode, and then the data node, we literally see everything end to end. And that gives us a lot of understanding of how to optimize I/O and how to account for things that are in the way.
Nice. Nice. What else can we see in here? Because we are coming towards the end of the things we want to show, because we've deployed out the whole environment. We've got both new hosts and existing hosts added to it. We've got VMs running.
And I'd say all relatively painless for the most part.
Well, I am no more bored than I was when I started this engagement, and at no point have we had to escalate beyond you and, well, I barely needed you in this other than keep the conversation going.
Really, you pretty much had this down. Ultimately, had we hit any kind of a snag here, it's pretty typical process for us that we would engage with support and check in with them. Also, as part of any successful install, our partners and/or our SEs will make a phone call to support, validate that the system is online, ask support if there's anything weird that they see, and then feed that back to the customer that, hey, we've got communications, we're up and running. This system is now being monitored 24/7, 365, and any alert that comes out will create a case automatically, and then we validate the phone tree with the customer of who we're going to call and things like that. So those are all the other surrounding contributory steps of what we would do. Yeah. Within the UI here, one of the things that we can look at that's pretty slick is historical view. And if we mentally kind of map forward to, hey, we've had this running for a month or two, and we look at this, we basically are collecting statistical information for the purposes of analytics, but we keep it native to the solution on premise. And one of the things that many of us have learned that have come from other technology vendors is that customers really appreciate analytics packages. They appreciate if they're simple, and they don't necessarily like to log into the cloud to get them. And so we developed a strategy to embed all of this within the user interface, but provide 365 days of look back native to this install. Oh, nice. So I have per second stats that range out to a few hours. I have hourly stats that range out to a number of days. I have daily stats that range out to a year. And then at 366 days, they roll off.
Age out. Yep.
Yeah, but this is providing me a capability to go and analyze the environment, and not spending too much time on this, because this is just a fun one to kind of poke around and see. And there's some great demos on the Datrium YouTube channel that kind of focus on this and go through this, so I won't belabor this, but you have the control to really elect and report on any specific category or criteria. So anything around latency, I/O throughput, flash utilization, dedupe and compression, how much of the data store that you're using, all of those things are represented here, and that you can time slice those and then even drill down on a per VM basis to see these. So I can look at a daily view, weekly, monthly, yearly view, and then be able to go and highlight what I want to see.
So for the build day, we would have liked to have had a last hour view, because that's all the data we've actually got in.
Exactly,
here.
yeah, exactly.
Yeah, there's the latencies inside the device, latencies and available capacity. Queue depths as well, that's interesting.
And we can filter really on anything. We're currently in a host view, so we're looking at history that is germane to this individual host. I could even drill down and look at 365 days of history on one VM, or I can go all the way back up to the cluster level and have that same historical view for the entire cluster. So it truly is a full and integrated analytics package that's just kind of built into the UI.
So if I drill into Datrium DVX for the first VM we migrated on, I'm going to get a whole heap of VM-specific stats.
And so you see historical stuff right here. We got historical charts there as well.
It stopped running the workload that it was originally running.
It did, yeah.
But my historical charts are in here, and cache hit rate of 100%, we like that. IOPS, you can see when the workload was running inside it,
when it dropped,
when it stopped off.
Yeah.
Nice.
Yeah, so a lot of folks find this useful. One of the anecdotes that I've had recently that was kind of cool was a customer said to me, I've kind of recognized after using this for 6 months or so that, and this was up in Seattle, they said, it takes me no more than about maybe 5 to 10 seconds to find, a really, really heavy workload in the environment. And that used to be a tough thing for them to do. That they could just scope the historical view at the cluster level and see by stack ranking, and that's something that we do in that top line view, by stack ranking, who has the highest read I/O, who has the highest write I/O, who has the highest latency. All those bubble up to the surface, and we make that incredibly easy. So in that right-hand pane, that far right-hand column of the screen here, you can pick what things you want to look at, and you can turn on or off things at your desire, and then mine that for information, and it just bubbles right up to the surface, either in real time or at any point historically. You can also bracket, so not dissimilar to video editing, Jeffrey, that we actually have a capability here to kind of time squeeze and even scrub back and forth across time using that top time graph.
So if I
that you
pull
can
this
just
in, we can expand out today's range.
Exactly, and so you can get more granular and really drill down into the peaks and valleys of what's been going on, and understand what's happening there. This is something. There are internal to our SE core that there are a couple of things that we call giggle moments. When we're doing demos for customers of our lab environment, this is a giggle moment. When we show this to a long-time VM admin that has had to struggle through finding top-line workloads and stuff, and they look at this, that you will get the like that sort of And I love. I can't
wait to have this in place.
Yeah, right. I love hearing that. I mean, that really tells us, okay, this is the right stuff. We're doing the right things. Yeah, so that's kind of some other interesting anecdotes. We talked about protection a bit, but now we've had some snapshots going. It might be a good idea to just go take a look at that and see what we've got in our primary snapshot view. we can now see that, yeah, we have our 2 policies, and we have some snapshots associated with gold.
With the gold, because of course the lead one happens at midnight, and so we won't be here for that one.
For a while, yeah.
At least not in this time zone.
Yeah, so if you drill down on that, that will show us, if you scroll down there, our snapshot history. And this is what Sazzala was talking about. We've developed this isolation between the data store and the snap store. And the snap store is independently browsable, that I can now go look at the history of snapshots and indeed the VMs and the files under them, and that is atomic and separate from the data store itself. So I can manipulate things here with absolute guarantee that there is no impact to the production workload, that there is nothing related to that at all. And I can do things out of order. I can go back and grab a snapshot out of history. I can clone it, do a zero-copy clone. I can stand it up as a restoration to a different location. I can manually replicate it to another site if I had some utility for that. It's very agile in that regard, and all the while leaving the VMs themselves alone.
Nicely. So all the way in, I've drilled into one of the particular snapshots, and we can see the VMs that were in that snapshot. And I can choose that snapshot and choose to take some actions.
Yep. And if you drill down on the blue link for that particular item, then you'll also see the files that are underneath that. And that really gives us that representation of the file level granularity and then manipulation at the file level.
To go, that took me to the properties of the actual VM that was being
snapped. It dropped us to the VM. I'm sorry, I apologize. Wrong part of the screen to click on. But the intent there is to give you that granularity to even go and recover a file. Maybe that's a vDisk with a big database on it or something like that. Really be able to drill down and have that control.
So when I choose him, I could come over here and I could choose one of these files, and I could actually bring just the VMX file, because occasionally I've had situations where ESX, and very old versions of ESX, but ESX has corrupted my VMX config file.
Oh yeah, sure.
And that doesn't change often, so I just restore it from a backup.
Right, and then you're good to go.
Nice.
Yeah, I mean, in essence, from our run list, we have covered really all the major points of what we would do during a customer build. And I spend some time oftentimes doing a management UI walkthrough. We've done a little bit about that, and again, there's a lot more online resource for that. If folks want to learn more, I sent you over a couple of things that you might bring up on the screen just in slides of where folks can go to look at what it is that we're doing. I think I emailed you a different thing, but the basics of understanding how to implement Datrium are really covered in what we did today. So hopefully this was useful for folks. We have a YouTube channel that's very lively. We have a fantastic presence out on LinkedIn as well, and you can find us in a number of other places. But there are always some resources that are go-to resources. We do Webinar Wednesdays, and Webinar Wednesdays, if you just hit our site datrium.com/webinars, you can log yourself in and register for webinars that come up every Wednesday. And they are ranging between high-level topics to very technical deep dive topics and walkthroughs and demos and things like that. Often Mike facilitates a lot of those, and a lot of the folks, we have guest speakers come in from partners, and sometimes our customers come and speak on those as well. So really anything that they need, there's a lot of resource out there available.
Excellent. And I think this is time to thank a couple of people who haven't been on camera. In particular, Craig Nunes, who was my first contact here and has facilitated a number of things that I've done with Datrium. Thank you for your continued support. And we had some help from the support team, Joe and some of the support crew, as well as Zach, who came in to help us with some of our Cisco issues. And if we'd called him in 24 hours earlier, I think that Mike would have more hair remaining on his head. And also, Lloyda, who's been out here in reception trying to shush everybody so that we didn't get too much noise coming in through. Do keep an eye on the vBrownBag YouTube channel. All of the videos, in particular the IO architecture video and the drive failure video that I did with Lakshmi yesterday, those will both be up on the YouTube channel shortly, as well as the complete version of the IO architecture, the IO architecture and the DVX platform architecture that you and I did. We only had a piece of it in this run. So yeah, stay with us on the vBrownBag channel. But I think for today's build day, we've had a really successful time, built out a nice piece of infrastructure. And unfortunately, I'm not going to get time to play with this infrastructure and get all the best of this performance.
Oh, that's all right. It doesn't matter that you will still receive your Datrium Certified Installer certificate official, that you are now absolutely capable of going out and rolling these out in the field. So for a small consulting fee, folks could call on you to come out and do their Datrium installs.
Indeed, and the fee will include quite a large travel fee for those not based in New Zealand.
Exactly. Exactly.
Thank you very much, Devin Hamilton, for spending
A pleasure.
three hours with me in the live stream.
Really enjoyed it. Thank you very much, Alastair.
And thank you all for joining us too.